Oh, I didn't paste the link to the materials. God. Here we go. So we have 4. We have the 2 APHA guys looking for a park at the moment, which I wish them all the luck. Best of luck trying to find a parking space at the south. And then there's, I think we have maybe 10 people dialing in, which is interesting. They're not interacting with me though. I don't know why. Yeah, you go down here, down the stairs where you entered, and you just keep going that way, like literally that way.
So downstairs and come left.
Yes, go down the stairs, and it's actually behind you, so you come downstairs that way.
I'll come down with you. I'm on there now, aren't I?
Did you?
Yeah.
Hi, Keys. Oh, there's one.
Yeah, I was me.
Hi, Keys. Yeah, I can see you. Good job. Got the question thing working there. There's real people.
Right?
There's real people. They all want to grab coffee.
There's not. Example. It's the one thing what about something you don't know about is that you don't know about it.
You are on the screen. You're actually broadcasting to. There's 7 or 8 people watching you.
Oh God.
So I see most of you opted to go for the public link. Keep in mind, you can actually join the Hangouts directly the way Martin and Karina has, so you can see and interact using your microphone and video as well. That is the second link, I think, in the email. It goes hangouts.google.com/ and a whole bunch of gibberish. Right. Hello? Yeah. Yeah. So yeah, just grab a spot and
Oh,
so yes, good.
okay. I have a computer with me, but this is a kind of office computer. I'm not sure I can use here. I can only use locally. So this is kind of like a very weird security thing.
Yeah, I guess I have a moment.
Yeah, so only five or maybe six people together.
Hello.
Fine. Terrible.
Oh, hi.
Hi.
So, you asked them?
Yes, that's right. Yeah, we're both in a separate apartment. Yeah, we live in Salmon Meadow, two Dolman.
Yeah.
Yeah.
Yeah. If you come back,
Good, good, I think.
Oh, really?
Yeah.
This going?
Oh, God. Yeah. Is this like a little interesting? Is it something like phone?
Yeah.
Something like that. Yeah, yeah. Interesting.
Oh, really? It's like, it's a,
Yeah.
No, no,
You know whoever the
no. No, no.
You using that API phone?
yeah.
Is it really looking for work phone?
Yeah.
You sent everybody an email. People are going to be on the hangout. Hello, not fine.
They might as well.
Okay.
If you have headphones, you can check the sound quality. That would be good. So I've got them somewhere.
You got anything
They don't need a full account though.
Pardon?
They don't need an account.
Oh, they don't.
Oh, the hangout. Oh, right, yeah. That's you're way ahead.
It's got a link to the source material there on the email as well, hasn't it?
Yeah, I turned another one actually.
Do you export it to one more desktop?
Yeah, sure.
I'm not sure I can do it.
So I think there's probably that. Okay, so hi Miguel, yes, I did receive your question.
No, this one is Office computer because it's security.
Oh.
I cannot log into any. I
No.
only use locally.
Yeah.
So can we have another computer?
No, we only have one spare.
Oh,
I mean, you both can look on. You're not.
yeah.
It's not like. um,
Right.
Hi Miguel, this should be coming out loud and clear. Just let me know in the question and answer box. Are the rest of you on the Hangout? Because if you're on it, even though you can see me, you can't see what the others are saying through the question.
Right.
So
We go on the internet. Yeah, that's one of my. I'm
Yes, there's a bit of disruptive stuff, so I keep muting it on and off. I'm assuming everyone can hear me now, right? I'm kind of expecting something to go wrong, so I keep hesitating. All right, we'll start. We'll start soon. If you're wondering, you should see in the top right a few squares, I think. And if you click that, you'll get access to the little Q and answer app, and then you can see questions that other people are asking, and we'll be interacting through that today. If you're on the Hangout directly, which I think is just Martin and Karina, that link is on your left. Hi, Stefan. Good to finally interact with you in a very one-sided, strange way. Are you two online? Yeah. When you're on the Hangouts, you can see everything. Yeah. Try posting a question from your end. No, I haven't got a Hangout chat.
No, say it again. Yeah. You were at Tom. Yeah. Okay. And you're from the APHA?
Yeah.
Have a good trip?
Yeah, quite all right, yeah.
You come from Wadebridge?
Yes.
When I go down to Wadebridge, I take Crossway, which is a wonderful way to drive. I don't know, nothing like motorway or much. Wow. It's tough to be the Crossway just goes all the way down from villages and everything. It might be a little bit longer, but it'd be a lot nicer.
Yeah.
If you're still downloading the course, well, you should try and start downloading the course materials, and particularly the test data. You won't need that for at least another hour while we go to the first part of the course. So it's okay if it hasn't finished yet, but yeah, I would recommend you start you to have a look at that now.
So Nabil, should I connect to the Google Hangout or how do I do this?
Yes, please. So all the physical participants, if they're on the Google Hangout, they can see the questions that the
We're not
online
putting them
people-
up here on the screen?
Well, they'll come up here as well. But I might, when I'm showing on EnteroBase and things, you won't see this the Hangouts, this dash behind me anymore. So it's good to have your own copy. Hello, Anthony. Can you hear me? Yeah.
I hope you don't get this microphone problem that I had last time.
The what?
Echo on the microphone from the people talking.
Well, the lucky part is that I get to control it from here. Actually, I get I get a dashboard at the back, so I'll mute and I can mute everyone's microphone myself. So I've muted Martin's, for instance. Yeah, I did. I saw that. So yeah, so test questions working fine. How soon will we be starting? I'll be starting anytime now. I did say we'd start officially at 11, so we can kick on now. I was assuming we'd have more problems. We got 20 people chanting at the bit now, I think. So,
20 people?
yeah, 20 viewers.
Where'd you get that many people from? Just all came to last moment?
Yeah, I guess so. Should we make a start, Martin?
Yeah.
Where's Marie gone? Okay.
Disappeared.
Okay, we'll just start in a minute or so. So yeah, just grab a quick cup of coffee and then we'll begin.
If German, you can all again. You know, so there's only 4 people. Here, there's a chair over. Now we've got to find a link. This is a link. How do I log into this course? Are we going to want? Now do.
So if you just click that link, you'll get open to the.
So I've got this EnteroBase training day.
Yeah. So just
With here. I'll just check my YouTube.
Yeah, so this works. Yeah.
you may wish to mute your microphone off. You could. Your speakers actually.
Okay.
Watching. That and then my email taking notes I can't get Google Hangout.
What are you connecting then?
I'm connecting by my phone.
One to connect by everyone.
I won't have what's next right now, but
It won't let you connect by everyone?
no, that's what Marie's ringing about. I've connected before, really.
But you can check this. Yeah, but which one's Marie working on? She's not working on that. Oh, I see. You're giving
Just log them in to your Edgewell. Use your credentials. What's the difference?
I can't remember what that.
No, it won't. No,
Yeah, I tried to use mine.
Well, one possibility is that we just give him mine, and that's,
Yeah, so they can share on that one.
Why don't we do that?
And yeah.
Or we can go to the
So,
So the first.
this is actually, the responsive finger or to the, to that pen, and otherwise the standard keyboard uses the mouse. Rightmost button will be down here, and left is in.
Okay, should
I'll
we?
go tell Marie.
Okay, yeah.
Marie, we're loaning you, my computer.
Okay. It's Murphy's Law, right? So, okay. So the thing that was supposed to go wrong has gone wrong. So I think now we can actually make a start. If everyone can try posting a question to the question application, if they haven't already. You can do this while I'm speaking today.
Where's this question now?
So if you go to the, if you just attach to the Hangout and you go to the top right, there's a little set of 9 squares. If you click that, there should be a Q&A option.
No, all I got here is okay.
Just show it.
Nobody counted it. Nabil, why don't you come over here and work with one of this stuff?
Martin, did you open it?
Making notes first while the link.
No, we're getting everyone on. No, the 9 squares. And then we ask the question. And so that comes up there, and then over the day I see it up on my screen, so then I can answer it. These messages.
Good audio from Taiwan.
Okay.
Okay.
So let's begin. Hopefully everyone can hear me. Might as well crack on. All right. So, hi everyone. I'm Nabil. I'm a junior postdoc with Mark Ackman and one of the developers on EnteroBase. You'll hear from Martin later on, who's another developer. But today we're going to take you through EnteroBase, how to use it. We have some test examples for you to play with. But right now I'll give a brief bit of background about what EnteroBase actually is and what we're really trying to achieve. So firstly, I think it comes no surprise that the cost of sequencing has decreased dramatically. So this is the classic chart that everyone uses that just shows the cost per megabase over time, and you can see that this is logarithmic, this particular chart on the y-axis, so it's been decreasing exponentially over the past 10 years. And what that's led to is a huge repository of sequence data for a number of different pathogens. So for Salmonella, that number is up to 45,000 sequence read archives, which can be all turned into separate Salmonella genomes. This is a huge increase in the amount of information available, considering that we have only 140 complete genomes available at the moment. Now, most of this data has been put up by a number of institutions like Public Health England, the Sanger Institute, FDA, CDC, and there are a few others in there. But all of this data is available, but not really in a form that we can all use it. And that's where the remit of EnteroBase comes in, which is to take this information and provide useful biological analysis results for everyone to interact with. So at the moment we provide 7-gene MLST, RMLST, CGMLST, we provide genome assemblies. We have now started with minimum spanning trees, with soon add genome annotations, and we're looking to add things like calculating SNPs and giving antibiotic resistance profiles. And we want to take all of this information and make it available for bioinformaticians, clinicians, epidemiologists, biologists, a very wide audience. So this is EnteroBase, what the basic interface looks like. So when you go to enterobase.warwick.ac.uk, you see this this dash of the available databases. This slide's a little old, but it shows you that even now, back then you have 40,000 genomes available in Salmonella for you to work with, 16,000 in Escherichia, and about 800 in Yersinia. Now the data we have not only leans on what's in public databases, but we've also integrated this with the classical 7-gene MLST databases. So that's mlst.warwick.ac.uk. That's been curated by Mark Ackman. And that data is presented alongside the genomic data in EnteroBase. So on the right, you'll see this is the basic interface of EnteroBase. So on the left, you have strain metadata. Most of this is pulled from NCBI. And on the right, you have experimental data. So in this example, you can see the assembly statistics for that given genome. At the moment, EnteroBase services about 370 users globally, which is impressive considering that we just launched the service back at the start of the year, and these are members of a range of major institutions across the world. So before we get too far into it, because in EnteroBase you can not only work with publicly available data, you can upload your own data and compare that to what's publicly available. But there's a few caveats with how your data. A lot of people ask us about how is your data handled in EnteroBase. So firstly, with your personal data, very simply, we don't do anything with your emails or any personal data you give to us. We don't keep track of your passwords. We may email you. For instance, I emailed everyone about this course, but we're not planning to do that on a regular basis or on an annoying basis. And then when it comes to your actual sequencing data, the raw reads that you upload to EnteroBase are never made public. So no one else can ever access these. The assemblies that are generated from your sequence reads are accessible to you and only you for a grace period of 6 months. So they're under embargo. They're just for you. After 6 months, they are then made public. Now this period can be made a bit longer in certain circumstances. Now, based off that assembly, we do all of the genotyping and analysis based on that, and that is made public pretty much as soon as it's generated. And we don't have any policies around obscuring metadata. So if you have, say, strain names that are possibly not anonymized to patients or anything, we don't do anything. We're not aware of this. We can't handle this. So that's something you'd have to do yourself before you upload your data into EnteroBase. We encourage you to enter as much metadata as you can as soon as possible. We accept that some things are sensitive and you can't really put as much as you'd like at a given time, but it's possible. Once you've submitted your data, you can go back and add that metadata and backfill it whenever you want. But we recommend that you do that as soon as possible because we want to have a comprehensive, useful database of information, of sequencing information, and that relies on good metadata. We're also interested in developing mirror sites for EnteroBase. So if you want to deploy it for other species other than the ones that I've presented, so that's Salmonella, Escherichia, Yersinia, and Marxella, we're interested in talking to you about that in the long term, about developing mirror sites. So that's all I have for basic slide sets. Hi, you can all see me now. Any questions so far? No, I think everyone's just testing out the question system. Any questions from the front here?
No.
No? Okay. Fair enough. So, where were we for the? No, that one. So I'll just get. I should have printed out the notes actually myself. So what are we covering today? Right. So I hope everyone. I'll share this on the Hangouts actually. Oh. Right. How's it looking on your end, Martin?
Because normally you're slightly late before it shows up in something. Now we got your face.
Right. Okay. So everyone will have the. I'm screening the manual at the moment.
There it is. You got the manual.
Okay. So everyone's got the. Everyone's looking at a copy of the manual. So I emailed a Dropbox link which has all of the course materials in it, and one of the documents was the manual. Now the manual isn't finished, but there is some very useful information on how to get started and how to use EnteroBase. The first thing is everyone should try and obviously register with the service. So if you haven't done that, you can do that now. I'm not sure if I want to use. Yeah, so we can do that on screen as well. And I'll show you how to log in. So I'll switch to. See. There we go. Right. So everyone should. So on your screens, you see the empty window. Okay. So this is the front page of EnteroBase, and if you haven't done this already, you can follow along with me and just register. So you have to register at the moment to access any of the resources. There's nothing particularly. It's not very difficult to register. All you need is just a username, training, and you can just enter in an account I haven't used on there. It might throw me out. So that's me. Oh, that's my institution. Department. Right, and then once you've filled out the form, it's just a simple web form. You click register. Oops. And it'll prompt you if you've made any mistakes. So, which, fortunately, I use every single email on the site. It won't say that for you. It'll say that it's registered for you. So, are you two haven't registered, right?
Just register.
Okay.
I think before.
About metadata. Okay, so while everyone is registering, I'll answer this question from Lorena. It reads, so about metadata, probably it would be published a list of public data not in conflict with our national privacy norms. Yeah, so ideally people would, I mean, there's no, we don't have very strict controls on metadata. So if you have any privacy restrictions, you don't have to put that information into the website. But what my point is in the slides was that is something that is up to you. We can't go back and anonymize data for you. We would because we don't know what it means. It doesn't look like it just looks like a record that just has some information attached to it. And then everyone else is saying great audio quality. So I'm assuming everyone has been able to successfully register. We've lost a few people. Okay. So if you're having any difficulty, if you go to the manual, so I'll just switch to showing everyone the manual again. So if you go to the manual on PDF.
Emails already registered. So yeah, email already registered. So you
So that-
already have a username. You know your username?
So yeah, so under chapter 1 on page 5, there's basically what we're discussing, which is the sort of an overview of the front page and how to register and information on how to log in. So we'll have a go at trying to log in now, actually.
You know your password because all you have to do is just log in. You don't need to register if you're a known user.
So if you're basing it specifically twice,
Because the reason is you click on register, and what you now need to do is go to your email account and look at your email that you received.
Done registering. Okay, thanks, Hickeys. So if people could use the question box. Oh, Karina's back. If people could use the question box, those of you viewing, and just post whether you've registered or not successfully, and then we'll move on. Is the manual available online? Yes, it is. I emailed it's not publicly available online. I did email a link, but Sylvia Garcia, I'm not sure if I emailed it to you. What I will do is I will add it to the showcase.
Now we're having a problem here because it says the email's already read, so it doesn't say it's an email.
That's fine.
You got that? Okay, fine.
Everything okay?
Yeah.
Okay.
Might be fine.
Yeah, probably is, yeah.
So if you're looking for, so someone was asking the question about the materials. If you haven't got the link, do you know where you got the Q&A option? There's another thing called Showcase. So if you click on Showcase, it'll show links that are available. So I like links that I post throughout the day. So one of them is a link to the training materials if you haven't had a look at it already.
So do you want people in EnteroBase or do you want people on the Google Hangout?
Well, they can vote.
Oh God.
Okay.
Okay, so that's your Hangout and that's your, okay, so okay, now you can click that.
Great, thank you. Okay, so
Except, why don't you see the phone next?
cheers, Sylvia.
No, so you're not logged in.
Great.
Click on your
Alrighty. Yeah, so Mark's question was, should you be on EnteroBase or should you be on the Hangouts? Ideally, you can work along with what I'm doing throughout the day. Feel free to try it out. But if you're stuck, or if that's too much at once, then you can just watch my screen as well and try it out later. All of the steps we're going through is in the manual, so it depends on how you wanna treat the material. Okay. Right, so let's actually log on and do something with the site. So once you registered, there's the login link in the top right. So if you click that, and then you can log in with the credentials that you just put into the register or with your normal credentials. No, actually, hold on. So this is the main dashboard of EnteroBase, and it shows all of the available databases. Ignore Mycobacterium, that's my secret one that no one knows about until now. But if you ever want to access a particular database, you just click the link down of the bottom of all of the information that says database home. So on this, you see Salmonella. It tells you how many strain records there are, the breakdown of where they're coming from. So 7,000 from MLST, 45,000 from sequence reads, and then there's information about all of the genotyping schemes or experimental schemes we've applied to that data. All right. So if you click Database Home, you get this dash that shows you a lot of links. Hi, Derek. Derek in Glasgow here. Oh, hi, Derek. Everyone say hi to Derek in Glasgow. Okay. So this is where this is a basic dashboard. There's a separate one for each of the databases. So I mean, if you go to Escherichia, you see that there's one for Escherichia shigella. We'll be playing in Salmonella for most of the day. So I'll just give you an overview of sort of this interface of what's going on. If you scroll down, so there's important information underneath this colorful set of links. Then there's some notifications, some graphs on data in that particular database, which is fun to look at. And up here, there's information on how to do user management, so things like changing your password, changing your emails, logging out, changing your personal information, and so on. So that's up here. And then this link, Species Home, just takes you back to this page. And then if you go into tasks, this is where all of the interesting stuff is. So things like uploading reads, which Martin will show you in a little while, searching strains, showing your job, showing your buddies. So we'll be working through search strains and my buddies now. So if you go to search strains, so everyone click on search strains. I'll give you a second to do that. Hopefully you're able to get to this point. And there's two Karinas. Okay. So if you go to search strains, you're presented with a basic search. Well, actually, it's a very complicated search window. And the example in the manual, I'll take you through it. And if you want to just watch my screen, or if you want to try it yourself while I'm talking and sort of giving the cues, then you can do that as well. So in the manual, we had a question. The question is really simple. I want to find all of the Salmonella of Serovar Newport, and so serotype, so Serovar Newport, and I want to find all of these from the United Kingdom. So I want the two things: UK related Newports. All right, fine. So if you have the search window open, you go to Serovar. Then you type in Newport. Once you start typing a few letters, you get to see all of the possible options. So you can just click the first one, Newport. Then you click and you can have another. Then you can add another condition to your search. So we wanted country. So down under location, you have country, and you write United, and it'll try to fill it up. So United Kingdom. Okay, fine. So that's a basic search. If you once you've done that, you press submit, and then it'll wait. You wait a second, and you get this data back.
What if you type UK?
UK won't recognize it because in the it's always called United Kingdom in the metadata. If you're searching, the autocomplete will tell you what sort of. If you type in UK, what happens? Nothing. It's like three letters. Right. So yeah. So let's see if anyone's had it. So everyone followed me so far? I get this server encountered an internal error and was unable to trying to complete the service over there. Stefan, if you have that problem, I'd suggest you just keep trying, I suppose. Just refresh the page and try again. Interesting. Let me know if that doesn't work though. Okay, now I'm in. Okay, yeah. Alright, good. Alright. Bit difficult to manage because I don't know where everyone is on the page. Hopefully, if you lose track of me throughout the day, you can just go to the manual and just work through that to see what I've been doing. But so right now we're looking at new ports from the United Kingdom. This is all of the searches. Results in. Sorry, someone dropped something. No. All okay in Galway. Cheers, Karina. All right, so now we're looking at all of the new ports from the United Kingdom. So here on the left panel, there's a panel here. There's a pane like this. There is strain metadata. If you scroll to the right, you can see that strain name, where it's from. If you click on that, it gives you more information about where it's from. The location, it gives you a nice map. They're all from the UK, which is what we wanted. Who submitted that data, and some more information about them to the right. On the left, you have experimental data. So this has things like about the assembly. It has things about MLST and so on, which you can change from this drop down here on the top right. So you can pick any of these experimental data from the drop down, and you'll be able to see the results for that relative to the strain on the left. Right. Now, data source. So the way we represent legacy from the old MLST database is that it's MLST legacy, and obviously in this case we're looking at the assembly information. Because this data was based on Sanger traces, there is no NGS data, so there's no assembly, there's no information about N50 or anything, because that doesn't really apply. When you scroll down, you see things about data from the SRA. So you have the accession, the SRA accession, and you have information about the assembly. So all of that's there. You can look at the 7-gene MLST data by going to the drop-down and clicking on that, and you've got all of that information there for you. It's just that easy of just browsing to the site. Right. So if you click on assembly stats on the top, and you click on the status here, it'll download the assembly for you. If you open that in a text in Notepad or something, you'll have all of the assembled sequence there for you to use offline in your own analysis. Oh, okay. So I'll just check if everyone's with us. Yep. Okay. So hopefully everyone has followed along that far. So so now you know how to basically do a search. You know how to download some contigs. You now know how to sort of quickly scroll around through some of the basic information about these strains. I'll show you how to do some more complicated searches and how to save searches. So if you go back to data on the top left and you go to search strains, or you can use tasks search strains on the far left. You come back to your search. There are a number of options on the top which can help you out with your searches. So this one in particular is interesting. Ignore legacy data. Now, when you want to just work with genomes, you just check this. And if you submit the search, it will remove all of those records that we're saying. So now you don't see those old legacy MLST records. So these are all assembled, all assembly-based data. Here are editable strains. So only editable strains are the ones that you own or you have rights to edit. So they're sort of like search for all of the UK new ports that I can make changes to the metadata. Show failed assemblies. So we have a quality control evaluation for assemblies. We allow it to be assembled, but then we don't use it for any downstream analysis because we don't trust it. So these are things that haven't assembled very well: low N50s, too many contigs, contaminated, or anything like that. So we take them out. You can see those show failed assemblies, and let's hope for a couple come up. Oh, I forgot to take up that. So you can see fail QC, and it's got in red why this failed QC. It's too long, too big for a salmonella to be 5.8, or this one down here is like 7 megabases, and we have Kraken running in the background that gives you a breakdown of the species, and it says that actually the majority of it is E. coli. So something horrible has gone wrong there, and you shouldn't really use it. But if you want to use it, or if you want to download it, you can just click it and download it, and you can work with it, work with that data if you want. Yeah, so if you want to do, and we also have some one-click searches for things like you want to find strains that are just belonging to you. You click My Strains. Well, this one's a nice one. You just find the latest. You just want to see what's in the database in the last like 200 records of the database. So you click latest to latest, and you can change that number. So this is the latest 200. The search strains, you can go to say latest 100 only. You click that, and that'll just give you the latest 100 records back to you. Yeah. Now, when you write these, you can write some very complicated queries into EnteroBase. Let's see if everyone's going okay. Yeah, everyone's going okay. So it's, hey, you know, I mean, you don't want to keep writing in Newport, United Kingdom every time you want to look this up. So what you can do is, at the top right, there's Save Current Query. And in Save Current Query, you can just write, let's say, UK_Newport, something like that. And you click this icon. It's an old floppy disk icon with the download symbol. Click that, and that saves it. And when you go to load, you can see UK_Newport saved down here. So let's say I clear this, and there's nothing there. And I've just come back to the site, and I haven't done anything. I can come down here, click on that one, click load, which is on the right, which is the one with the arrow pointing up, and the search is back. So this way, you don't have to do painstaking, you know, write a very nice search and then have to and then lose all of the lose that settings. The other thing Gemin insisted I showed you today was the in function. Now, not many people seem to pick up on this. Yes, you can write contains United Kingdom, but let's say we wanted not just Newport, we wanted. So if you click on that, set the operator to in. So now what you can do is you can give it a list. Now this list can be something you've copied out of an Excel spreadsheet or something like that of interesting, in this case, Cerebar. So let's say we want Newport and we want Gona and we want, what's another Cerebar?
Nabil, do a return, don't do commas. Just go ahead and do a return.
Yep, okay. Yeah, so you can do it that way. Yeah, so Newport, Agona, Hyphy. Too many in one go. You get a lot of them sit there thinking. Let's say Montevideo. Right, and you submit. So that's loaded 3 of these in, and we just do submit. And now you'll see in Cerebar, you can see Agona, Newport, Montevideo, all from the United Kingdom, or from England. Yeah. You've got all of these there. So you can, so that list can be 10 records that you've taken out of a spreadsheet, and you can copy it straight into that, one line, one after the other, and you can just do a search that way. And you can save that. You can save that in your save function and come back to it whenever you want. So, okay, so questions from Mark. When you save a query and load it in the future, it will only upload to the previous date, or will it do an updated search on the day you load it? Okay, that's actually a good question. So this is just the search that is saved. So if new records are added subsequently, then they'll come up in your search. So this is sort of dynamic. It's not. It's the results aren't fixed. The conditions of your search are fixed.
Now we want to show them the workspace.
Yep, we'll show them the workspace. Yep. So is the data in EnteroBase from uploaded sequences, or do you have WGS from the NCBI archives? Yeah, so they're from the so the data we have in EnteroBase includes data from the sequence read archive. Those are just short reads, they're just reads. We assemble ourselves. We have complete genomes, so from RefSec complete genomes, they're in there as well. And uploaded data that users put into the system as well. We don't have any of the draft genomes in the assembly databases. We don't trust we can't reconcile how they were done, and we can't trust them, so we don't put them in there. But they're quite inconsequential. I mean, there's not that many, considering in the scope of how many sequences there are actually not that many draft genomes out there. So you're not missing very much. So yeah, so we'll move on to workspaces. So, right, as Mark pointed out, this query is just going to show if someone adds a new, if you save this and you come back to it tomorrow, you won't get the same results because someone can subsequently add more new ports or agonas in the meantime, and you'll see all of those as well. If you're going to do a project and you want to say, hey, I want to have a fixed set that I'm going to use as a data set as I go through this project, then you need to introduce a workspace. So workspace is up here in the top under workspace. And it's just a simple, in this case, you take search results that you already have and you can just click save. And you can, this is agona, you know, UK, and just say others, and you can say save. And as workspace saved, you can share by going to the buddy space. So also, you can manipulate works. So now, if you go to load, so I'll just clear this. So I'll just do the latest 200. So it just gives me different results. So there's all this here. Okay, fine. If I go here, load, and I scroll down, agona others.uk, I click on that. There you go. All the results are back. So this is fixed. This does not, these records don't change. There will always be 400 records, 407 records in this set. There are other ways to manipulate it. So you can select, so if you're doing a normal search and you're clicking around, you can select a bunch and you can do things like add selected to another workspace, so I can add it to this one, and they've been added to that work group. You can delete these. So let's say I don't like, I have a particular predilection against this strain and I don't like it. I can say delete, and that'll go away from the workspace. So now it's gone down to 406. Yeah, and then you need to save it again after you've deleted it. So save it again, and so now that strain has been removed. You can do things like if you, whoops, you can select a bunch. So to select things in EnteroBase, you can click on it, hold Shift, and click down here, and it'll select a whole row like that. You can do things like this. You can if you've got a search, you can copy strains like this, make a new workspace, or open an existing workspace. So new is to create a new one, and you can do paste. And those ones I've selected just show up there. So you can manipulate data just quite robustly, and you can do a lot of things with workspaces and to sort of corral data together.
I get somebody.
Yeah. Now.
So I've got a quick question.
Yes.
When you make a new workspace, if you haven't saved the previous one, is it gone?
Yeah.
Yeah. So the question is, if you've got well, you wouldn't have a workspace then because you haven't saved it. But if you have search results, right? If you have search results like this,
no, the answer is gone.
It's gone.
This is not Microsoft.
Yeah. Yeah, it's completely gone. We don't cache it. You can't go backwards or anything. Now, I have this workspace that I've created, which I want to share with my boss, Mark. And so what I'm going to do is I'm going to share that with him so he can look at that same set of data along with me, and he and I can both make changes if we own the strains. So what you can do is if you go to tasks and you go to My Buddies, you get, so this page is separate for each of the databases. So it's Manage Buddies for Salmonella. And I already have a few people here. But let's say I want to share let's say I want to make, let's make Marie my buddy. There we go. Marie's my buddy now. I've added her. So I just enter her. I know her. Yeah, MA. So I just added her. So this gives you a list of the users, and it'll it'll give you suggestions. You can click on that, and then you hit Add Buddy. It'll say record already exists because I've added her, and she's there in my list of buddies. Now, this I'll just explain this table. So all of your buddies are here one after the other in individual rows. This box, edit strain metadata, it tells the database, I want to give global editing permission to all of my records in this database. So if I check this box and give it to Marie, she can take all of the strains that I own and make changes to it. This is important where, let's say, you have a student or someone who comes up with a set of data, and then you can go back and make corrections, or you can review it and make amendments on your data together.
Just about the workspace sharing, that's actually everything.
That's everything I have in Salmonella. You can play around with.
And you don't want to do that because you have to do it.
No, of course.
Yeah.
I completely understand.
So yeah. But today for Marie, I just want to share the workspace because we're collaborating on this wonderful project about Agona and others. So we're going to go to the Agona and others set. That's set 406 we defined earlier, and you just say OK, and it's that. You can add more at once. I mean, you can give her Agona and others. We'll give her another one I made about Newport, and so on. So you manipulate it all in there, and that's the set of the list of workspaces available to her, and then you click Update. And your records have been updated. So now, if Marie went, maybe Marie can confirm this for me. If she goes through her search.
Log out and let Marie log in.
Oh, okay. Oh, no, it's okay. Never mind. Actually, who is logged onto the system?
Darren ready.
Okay, we'll give it to Darren. Let's give it to Darren. Darren is another. That's Derek Brown. Darren ready. D ready or Darren ready? D dot ready. Okay. D dot ready. Here we go. Okay, so I'll give you Agonas and others, and the other one. Now, what this looks like when someone shares you the workspace, if someone else shares you the workspace, and you go to, let's say you're in the search strains window. Go back to workspaces. When you hit load, it'll appear in your load set here. Even though it's not yours, but it'll be up here for you. That's where it shows up. If you're on the receiving end of having. No.
No, click on those.
Go back to the share. That's actually click on share.
Oh, maybe I didn't.
Just refreshing.
Let's see.
Yeah, you need to refresh the page. It's not automatic, so you need to refresh the page. If it's entering your buddy and he's on the computer, he needs to refresh his page.
Oh, right. Okay. Yeah. So that's one point. Pro tip from Martin is if you have to refresh the page. Your buddy has to refresh the page before he'll see it on his on his menu, but it does show up, right? Yeah. Okay.
Tell people that we think workspaces are the best thing since pancakes.
Yeah. So Mark, yes, we love the idea of workspaces. I mean, this just allows you to have a data set you can share with everyone, and everyone knows exactly what you're talking about in terms of data. So it's very, very powerful. we would love to, we want to work on it more so that this is not just something you can share with buddies, but you can get like a Dropbox link and it'll be a fixed set of data. So you could attach it to a paper and people on that, people in public could just be like, oh, okay, what did they use? Oh, here's a nice table, interactive table of all of the information they have and all of the associated data with those records. And then that can be made fixed and standardized.
You've done that in an application yet?
No, we haven't written that function yet. That's what we want to do. that's the function we want to add. But that's where we're going with that. So we see this as a very, very, very powerful tool. But you know, it's very simple but very powerful. That's workspaces and buddies. So that's it for me for the first chapter. If you're following along in the manual, Uberstrain is covered by Martin in the next section. So, yeah. So maybe we'll take a break for a minute or two, just catch a breather, and we'll switch over to Martin. We'll be showing you chapter 2, which is actually uploading data and manipulating data, your own data on EnteroBase. I'll just field this quick question from Rika while we're waiting. So, which assembler is used for assembling the reads in the SRA? Rika, if you go to the manual, there's on the last chapter, there's a little bit of information about the pipeline we use, but basically we use spades and we have our own I'll show it on the Hangout actually. Let's see. We go to manual. Okay. So yeah, so this is the workflow for the assemblies if anyone's wondering. We use sickle, spades, then we use BWA to do mapping back to check the accuracy of the base calling and to make sure there's good scaffolding, and we use Kraken to do the check for contamination, which is what you see in the assembly stats when it was saying that the E. coli was there. So those are the Kraken results there. Okay. Martin, do you want to come from this end, or do you
have a break still?
No, we'll carry on. It's already. I'll switch it back. You just needed browsing under, correct?
Yeah. Got the mic here.
Yeah. So everyone, so that's what everyone sees. 1, 2, 4. We see that.
And I can work on this.
So we can work on that's where we are.
Yeah.
So everybody sees what was yeah.
And everybody can hear me now.
You are public.
Yeah. Okay. So we click on EnteroBase on the top left, and it should show us all the databases. Now, I should have given everybody access to this developer sandbox here. Okay. So we want to go on the database tab. Now, this is just a test database. So we're going to upload some dummy sequences, and we can mess about and muck this up. It doesn't matter. It's not a real database. It's just for testing. Okay, so there we go. So we're following chapter 2, number 1, adding reads manually. So first of all, we go to the upload reads page. And we should get, yeah. Okay. Is everybody there? Okay. So first of all, we're going to enter reads manually. So if you've only got the odd one read, you can type it directly into this table here. You can add extra rows either by right-clicking on Insert Row or going to Edit and add Blank Row. Okay. So we're going to add a single read. So first of all, so for the metadata, you can see once in red a metadata that is required, and we're quite that labs at the moment, all you need is the name of the strain and a lab contact, and obviously the read files. Obviously, you can add extra metadata. So depending on what the field is, it's either a drop down or you can type it directly into the box. So for instance, location is actually a map where you can click onto it. But for the moment, we'll only do the name and the lab contact. So if you want to put some a name in, whatever. Remember, this is just a test database. So okay, so we've added our minimal metadata now, and now we need to add our read files. So if we click on here, you should get this drop-down box, and by default, everything is Illumina paired end with an insert size of 500. That's all it can take at the moment, but in the future we're hoping we can take PacBio and other reads. So at the moment, default and only settings is this. So we have to add our reads. So we click to add file, and hopefully
You can't take 250 or 300 or 700 or
so sorry. Yeah. So this. So the insert size here is the insert size of your library, but Zemin, as Mulabi told me, doesn't actually use that information at the moment. But it is there in the short read archive. It's a compulsory piece of information. So I think we've just kept it there because of that. And some assembly programs do actually use the insert size to work things out. So we might need it in the future. But 500 is like the average insert size you get when you make an X0 or XT library. But to be honest, the insert size doesn't matter. This is not related to your read length. Your read length is calculated when you upload your reads. Yeah, so you don't have to insert your read length because that's already known. Okay, so Nabil is
Dropbox.
Dropbox, yeah.
Go to 22. Yeah. No, up. It's under E. EnteroBase 22.
Oh yeah, sorry.
You'll have to. It's in there,
Mm-hmm.
but they've all kind
No, what are we looking at?
no, they have to unzip them first.
Okay, right. Sorry about that.
Yeah. Interview.
So it's not in my Dropbox. Did I have to download it, or is it there somewhere?
You have to. Well, they're on a Dropbox thing that email to everyone. I didn't know that to you though.
Oh, a different Dropbox.
Yeah, so there was one with just the slides and things like that for everyone.
I don't have it.
In temple.
No, it's not in here. It's up.
Hmm?
Go to open. That. That's your. So no one can see you doing that, by the way.
Okay, right.
You can only see the page.
Okay, so where do you put it now?
Okay, so I just put it back in the training course folder.
Okay.
It's slowly extracting everything. So let's see. Yeah, you can click on that one. And people ask questions. Okay, so yeah, so everyone can see that. How would we link metadata file with reads file? You want to answer that?
Yeah. Okay, so just had the question, how would you link metadata file with reads file? So that is actually the second part of this exercise. So at the moment we're typing our metadata in manually, but you can upload it in the file and associate it with read files. But that's the second part of the exercise.
Okay, so
Yeah. So yeah, so we're going to put our reads in. Okay. Okay. And you can see now that because we've satisfied all the requirements, this submit button here has become active and we can submit our metadata. Okay, so we'll submit it and then we're brought onto the uploaded read page. So this table just gives a summary of all the reads we have waiting to be uploaded, just a couple at the moment. And here are the 2 reads that are pending. So we'll start our upload. Okay? As you see, because I'm in the university, it's very quick. They've uploaded already, and they're just okay. So they've been uploaded now. Okay.
It's a warning window.
So more of this later. But if we go to the tasks, and you go to show my jobs, you should see that now it's being assembled. So the latest job is the read you've just uploaded being assembled. So we'll go back to upload reads, and so that's all very well if you've only got that's Nabil's fault. Right. But if you've got loads and loads of reads to upload, it's better to create the metadata in a file, either using Excel or better still using a script. So if we go to data and load local file, we've got this upload example here. So as mentioned, you can obtain a template at the address given in the manual. Yeah, so at the static example, upload template text. So we'll upload this file, and as you can see, it's got 3 reads here, and it specified the name of the read files and it's linked into the metadata. Yeah.
What directory are you under? How does it open?
Ah, right. That's a good point. Okay. So as I mentioned in the manual, it doesn't. You only give them the read name. You don't specify the directory. You could do, but even if you did specify the directory, the browser wouldn't be able to pick them up because of very tight security restrictions in the browser. The only time a browser can manipulate a file is when you physically click on it. That's to stop it from going into your computer and stealing files. Yeah. So when we go to submit data now, you can see they haven't been. They're not on the pending site because your browser doesn't know about them, and the status is awaiting upload rather than local upload. So what you have to do now, you can either drag and drop those from a File Explorer window into the right-hand side here, or you can specify the directory where they are. Okay, so Dropbox. Where is it? Nabil, yeah? What? Oh, here. Sorry. Dropbox, yeah? And yeah. So these files were in the test data course here. So if we OK that now, we can see the computer has, the browser has now recognized them and they're ready to upload. Yeah. These are being uploaded by HTTP, so it's not the greatest. If you've got loads and loads of files, I have got a system where they can be picked up from an FTP site. So if you're not if you're not too worried about security, I can give you the password and address of Dropbox I have on EBI, and you can put them up there and they'll be picked up. Or you can give me your password of a FTP site that you use. But in the future, we're hoping to use is it Illumina MySpace and other such things. But FTP is an option.
If you have a lot of data.
Yeah, if you have a lot of data, just contact me on the bill. So we'll start out hundreds of sequences. So if you've got like hundreds of sequences, you'd still load them up in a file like this, and there'd be a waiting upload, and then you just contact me with I'll give you my FTP address, or you give me one, and then I could link them. Okay, so we're uploading everything now. Okay. Okay.
You've seen what?
Like you've seen, I mean, FX had 400 things being uploaded. You could go forward. Yeah. No, it was 400 a day.
400 a day.
Okay. So again, that was very quick because we're inside the university.
This is highly depends on the network connection.
Yeah.
So, if, for example, if you are from China, then the connection is slow, uploading one time to.
Oh, somebody from South Africa here.
Yeah.
Can you ask our South African user for the timing list? Mark.
Okay. Is anybody actually trying this? And how long is it taking for them to upload the reads? Okay.
Now how do you get to your message?
So go to Chrome.
No.
Go to the Hangout.
This one.
There you go.
Oh, well.
And you go to Q&A on the left. Yeah, that each row is a template. Which task files are you uploading?
Okay. So the template is in the test data course directory, upload example.
That won't be offline. It must be a template.
Oh yeah. The template is mentioned in the material.
No time at all to last.
Pardon?
Derek responded saying no time at all to last.
Right, okay. So yeah, the template is in enterbase.work.ac.uk static example upload template text. Although what you can also, that's page 14 on the manual, but what you can also do is if you go to tasks upload reads, at any time you can save to local file. So call it. At the moment, it'll just save the header row because there's nothing there. Pardon? Yeah. So you can save that and use that as your template. Yeah. You can see it's got all the headers up here that you need. Okay, so now we're going to see what's going on. So if we go to, shall I carry on? Yeah.
Yeah.
So if we go to show.
And they use Excel files with no problem. Right?
So.
Because they open that template file you showed them
Yes.
in Excel.
Yeah.
And then make changes in Excel. Would that work?
That would work, but they have to save it as tab delimited text. So I'm coming to that later where we download a file and change it. So these are the jobs that are currently running at the moment. So this is tasks, show my jobs. So by default, the last 200 jobs are shown and all types of jobs. You can, if you've got lots of jobs to manipulate, you can increase the limit and you can limit it to jobs that are running or ones that have failed or ones that are stale. And those ones that have been running longer than a day, so obviously there's something wrong with those. As you see, there's none here. So we go back to all. Okay, now everything should be done automatically. So once the assembly has finished, then jobs for the MLST and any other scheme in that database should be sent off. And if a job has failed, then every hour it checks any failed jobs and resends them. So you shouldn't have to do any of this, but there is facility for you to resend the jobs. So if you right click, that shows you the options of what you can do. So refresh selected jobs, all that will do is update the status. So there's actually, it goes through, when a job's sent off, it goes through 4 states. First one is waiting resource, then queued, then running, and then complete. But the job server will only call back when it's complete, so it won't go through the intermediates. But if you want to see whether it's actually running or whether it's in the wait resource or queued, you can refresh selected jobs. One thing I didn't mention is that if you click on the eye here, you see lots of detail about the actual job. Again, this is mainly for us. It's quite unless you know what it is. It's difficult to understand, but you can see it's got the status and the inputs. So you can also kill the job if you wanted to, and if the job has failed, you could resend it. Under some circumstances, if the job is still queued or running, but here you can see, well, for instance, it's queued here, but here you can see it's actually finished. That's because I haven't refreshed the page. So it's not real time. You have to refresh the page or refresh here for it to update. You can see a couple of already completed now. So this assembly is completed and it's sent off the 2 nomenclature jobs, which is the RMST and the MST admin, and that's finished. So as I was saying, if there was a disconnect between here and here, you can force reload on selected, so it will pull the job back in and process it. This shouldn't happen, but if there was a network connection or one of the servers was down for a while, then there might be a disconnect. But again, every hour, all this should be, there's a script that runs that should sort all this stuff out.
What is force reload?
Force reload just queries the Zemin's job server and pulls in all the information again. So if the callback for some reason hadn't reached this server, then it would pull all that information in again, yeah?
And that's different from a refresh?
Refresh, yeah, just updates. It doesn't pull any information, it just updates the status. But as I say, all this should be done automatically. Okay. So do you want to take a break now, or should we continue?
No, just check on the hangouts.
Yeah, check
Anyone
the
has
hangouts,
any
see what
questions?
it is about any responses to how I'm taking about this class. But
Okay, so there's some questions that have come up. Okay.
Yeah, so do the uploads cancel when we change to another task? The answer is yes, you have to keep on that web page. But if you do change the web page or there is a problem, you can always go back to that and upload the remaining reads. Only the read that is currently being uploaded will be disrupted. The ones that have already been uploaded will be fine. So you can return to the upload reads at any time and upload any remaining reads.
Are these templates uploaded only from WPS or Sanger? I don't understand.
No. So are these templates uploaded only from WPS or Sanger?
Hi, Keys. It's not clear what your question is. Are these templates uploaded only from WGS or Sanger? Are you talking about the actual fact about trace data? Because we only accept WGS data in EnteroBase. We don't accept Sanger traces anymore.
Only the Illumina actually.
And yeah, and of those WGS, it's only Illumina reads at the moment. We haven't implemented assemblies for 454, Packfire, and so on.
nor will we
Well, we're not doing 454 anyway. It's a bit past its time now, isn't it? Is that your?
Well,
Is that chapter 2?
No, I've got a bit more to do, yeah?
Yes, we'll finish chapter 2. So we had a break at 1.
A break at 1? Gosh.
Yeah, we had a.
Okay, so because I've got administrative sites, I can actually see other people's jobs as well. So if we have a look, see who else. So yeah, there's quite a few jobs being run at the moment, as you can see. So a few of you have managed to upload reads. Okay, so now we're going to edit metadata. So if we go back to tasks and search strains, have you got any? Have you uploaded? Oh, yeah. So,
my strains.
Yeah. So if we go to my strains, as in the manual, there's more than one way of doing this, but we'll click on the my strains here. Okay, so these are all the strains that Nabil owns in the test database.
Where is Sid stuff?
It has to be a real place. Let's see where it is. So this is in Hungary.
How do you find that?
I don't know.
You just click randomly on the map.
Well, the Rios, where is Rios?
Reyes is oh, I know what it is. Oh, I see that. Right.
Okay.
Yeah, okay.
Okay. So we need to go into edit mode to edit data. So we click on this box here. So we're on page 16, number 1. Okay. Click on edit mode. Okay. So the pencil icon means that we have rights for editing these records. Because I've gone to my strains, we've got rights on all of them. But just an example, if we were to go to all strains, so yeah, so Nabil's actually curator, so he has got edit rights. But what I wanted to show you is that the pencil icon would only be on the strains that you actually have permission to work with. If you go back to my strains, you can see here. So to edit data, you can just click on it and type. Also, you can bring up all the fields at once and move through them like this. Okay.
You didn't explain how you got there, Martin. What did you do to get to that?
Just click on the pencil icon, yeah. Okay. So once you make the changes, it turns yellow, but these aren't actually uploaded to the database. To do this, you can either right-click and upload changes. This will just do the single row, or you can upload all changes. So if we click on this icon here, upload changes, so we can see that the 2 records have been successfully updated. Okay.
If you don't click on update, it doesn't get saved.
No. So there is a search and replace function. Yeah. Okay, I've got to write that down. But it might be, if you've got loads and loads of records, it might be easy to edit them in a spreadsheet such as Excel. So again, you can save this to a local file. When you save any data, because of browser restrictions, it's actually classed as a download, so it can be downloaded to the download directory of your browser. Sometimes browsers allow you to choose which directory, but other times they don't. So if we save this as, can we open this in Excel?
Yeah, go open. No one can see what you're doing.
Okay, right. Okay, so
I can change the cursor, but that's fine. So what you can do? Oh yeah, you would do some other sources. Where is it? Yes. Okay. So what you can do is you can switch. So I'll just switch over to the spreadsheet of that information, which is this one. Yep. So should now see the
Oh, just
test.
look at messed up. Because,
Mhm.
it's got the semicolon.
No.
When you
No.
opened it, the semicolon was not,
Oh, I see. I didn't pass it.
yeah.
No, that's
No,
fine.
you didn't.
pass what?
No, that's fine. That's the behavior.
Yeah,
Is it?
Yeah.
yeah.
Oh,
Because that's a compound field of all of the data information. It's just in one cell like that. But that's fine.
So you can interesting stuff. When we save it, make sure we save it as text, tab delimited text. Okay. And then if we can then see that.
I'll switch you back. So is everyone following along with that? Let's see if you up this head. Yeah, so we've got sort of what happens when a file doesn't pass quality control? So if the file doesn't pass quality control, the status on the assembly in your records will say failed QC. And if you scroll to the right in assembly stats as the experimental data, you'll see why. It'll have a red block, why it's failed. You can still download the assemblies, and have a look why in detail what happened. Or you can contact us if you feel like, oh wait, this should be okay. You can contact us and we can actually override it from our end. But usually when it fails for a pretty good reason. So most of the time it's like someone's put yeah, well, what's that contaminant, proto or something or other. Or
What's it now? Proteus. Grows on everything. Swarms all across your plate.
Yeah.
You only need a single cell and it'll take over.
Yeah, and another thing is, normal user will notice to search it by default, you have to click one extra option
Yeah.
to get it first.
Yeah.
yeah, so
Nabil mentioned that.
yeah, so that's a good point. So if can everyone see me on the test page with cells now? Yes. So yeah. So if your data fails, you need to have this checked as well. Show failed assemblies, and then you'll get to see all of the ones that didn't make it when you do any of your sessions.
Okay, so what I'm going to do is, so
how do you get that text file back in?
yeah, so I've saved the file, manipulated it in a spreadsheet, and now if you go back to edit mode, okay, and you click on this icon here, which is load modified file. Okay, it was in download, isn't it?
Yeah.
Test. Okay. Okay, and you can see all the changes that I've made. Yeah. Okay, so you can either choose to upload them or whatever. Yeah. So you can either change stuff in here or in a spreadsheet, but you still have to press this, and then the records will be updated. Okay, so now we're going to move on to Uber strains, yeah?
Yeah, so we'll show the steps. Is
So
there
do you want
any
to do
questions?
this one? Or?
Yeah, I'll follow from the next one. Has anyone got any questions out of the people present here and online? Not talking Glasgow. So everyone's okay with that? I think we did see a few people who've uploaded jobs. So some people have successfully managed to go through the whole process. All right. So right. Okay. So back with me.
Your location, that's the country that's deposited the information, not where.
It's the when we say location, it's not so if it was sequenced by Sanger, it's kind of pointless to put United Kingdom as a location. We put usually this and in NCBI, this usually relates to the isolate source where they isolated it.
What would you like to travel like? Someone's travel, but it's a UK.
Yeah. So it's
Your choice.
it's your choice because it's already mixed in the database. I know you guys put the actual origin of the traveler,
Does make sense.
which makes
Yeah, but I'm not
sense.
sure whether on your template you've got an option for that, or whether you prefer
No.
to say it's from the UK.
We don't track
We
that
don't report that.
because
So just put down the source and you're happy with that and that's okay.
so
Yeah, but we also have a particular field called comment. Then you can put whatever you want to put.
yeah. All right. So yeah, if you've got sort of those sort of things, you can put them in comment. So this is foreign.
There's a metadata.
Yeah.
You download this table.
Yeah.
It's a minimal information, just like a manually. You get the sample names and the contact name. That's all you need. Or you have to have
That's
something else.
Well, the contact name and the strain name
Yeah.
is like the bare minimum
Yeah.
for it to be
we prefer
accepted.
more.
But we would yeah.
Year and
Everything
location.
on here. Everything you see is what we prefer.
So what we would like is there's some old of them. Let's see if we can find a good example. We like these kind of records, which are information and source and year and this is someone else has uploaded this. This is Tartan Rab. Yeah, but this is other people's rubbish that they've uploaded.
Okay.
Tartan Rab. I don't know who Tartan Rab is. Is that Derek? It's probably Derek. So we like it with all of this sort of information. This we don't like. This guy, Sal, Dr. B. Sorry, Dr. B. I mean, I'm just picking on you, but this is a record you see a lot, and we don't like this in published final data. Yeah, we prefer lots of metadata. Okay. Now, as people are up now, you have a. I mean, people don't think about this very much, right?
The reason we think it's good to put up as much as we can is that with the search functions that we'll be seeing in a moment, people will be looking, finding your strain in related to their strain, or you will be looking and finding other people's strains that are related to your strain. And so if you have epidemiological questions and you want to know, is this useful for you? It's good for you to have as much information as you can on other people's strains, and it's good for them to have as much information as you can provide on your strain. And we're seeing this being very, very useful for epidemiological purposes already, especially because we're planning to even go to the SNP level and whole genome level, and you're going to be drilling in and seeing who are the closest relatives at the global level. But if somebody has not put any information on, no use, and vice versa.
Yeah, but I guess the problem is in the beginning, when you do the research, the data can be sensitive. You don't want to give too much. Can we just give us say
Sensitive in which sense?
well, like the location, like all these things, and
Sensitive how?
well, eventually we're going to put everything in there. That's it. But now we just like to have.
Yeah. Okay. So I see your
Yeah.
your point. So the issue is about minimum amount of metadata and how you sort of handle it. We kind of accept that. Okay, fine. That if you've got an ongoing outbreak, and you can't say which country, which area of a country it's from because it impossibly implicates someone. and you don't have all the facts, you don't want to point fingers at people who aren't guilty, then yeah, you don't necessarily have to put that information up there at the time.
Now, if
but
on location, you don't have to fill in all the data. If all you want to give is the country and the region, it will accept that. If all you want to give is, if you want to give all the data, that's even better. You don't have to. But if you don't even give the country and the region, nobody can work with you, nobody can use your data, nobody can interact with you. And so if you're interested in something going on for food safety in Europe, or wanting to interact with other people concerned with food safety in Europe, you have to give them some information on those data. Now, you can make that information vague enough, like Scotland is not enough information to compromise anybody. You don't have to give, but if you can give all the information that's asked for, do it because this will help you interact with others.
And also your genomic data, your survey will never be released to public. And also when you attend it, we will have a 6 months penalty. Then they need to or after a year, nobody will share the data.
But isn't that just raw? We sample data as like
After that grace period, so the default is when you upload short reads the assembly of 5 or 6 months.
oh no.
Yes. Yeah, Martin, how do you do that?
You go to the upload.
So
And then
ah,
go to the laser period at the top.
oh, there you
The
go.
maximum is 12 months. No months. No, if you want, you can get available straight away.
So yeah, in 2 months or 1 month, you can make it available or whatever. Right.
And so what we're hearing is that people are already using EnteroBase like this to find out what are potential sources. So, for example, Germany was looking yesterday, and an old project that we had worked on was Theravar Argona from a food outbreak in Ireland in 2012, I think, 2008. And now suddenly we found some very closely related strains in the UK that are obviously closely related to this outbreak that was disseminated from Ireland in 2008, but these are from 2014. And so we're looking at this and we're saying, oh look, there may be a close relationship between these bacteria from the food outbreak in Ireland in 2008 that was led by Galway in the investigation, and what is going on in the UK now, and we didn't even know about it. And you find these things by accident. Or when we had a visit here from Liliana from the APHA a few weeks ago, we were starting to look through some of the salmonellas, and suddenly we're finding a strain of Kudugu that she's interested in. And it's all over the world, closely related to what is happening in the UK right now. And this is a source of information for you and your colleagues.
Yeah.
Put
So
in as much information.
so we'll show you how you can leverage that information. So we've been showing you how to click around, how to search, and how to upload data. I'm going to show you that. How do I remove uploaded strains? How do you remove uploaded strains? Yeah, you can't at the moment because
Too late.
too late.
Maybe I think if you do have some very strong reason to do that, contact them.
Yeah, if you we can remove it, but we don't allow. The issue is if you upload sequencing data and we call a genotype, we assign it a new ST, for instance. That's the proof for that ST. So if you remove it, then that's impossible to reconcile. I have some jobs in the queue. How do I kill them? Okay, so jobs in the queue. So hopefully you can see my browser window, job monitor. Well, wait, I don't want to show you the admin one. It's where all the dirty laundry is. Show my jobs under tasks.
They're all complete.
Yeah, they're all complete, and you can right click, kill selected jobs, and that's you killed them. You murderer. Right. Okay. So we'll press.
Here, tell Miguel that this is a sandbox. This is not public.
Oh yes, that's also another point. So the dev sandbox that we're all playing around in is not public. Only the participants can actually access it at the moment.
Yeah.
And all of the no one looks at this. This is just you can make as much mess as you want, and it doesn't matter. Feel free to just load in any old thing, and it's okay. Why did you put something sensitive up there? Just email me if you've accidentally put in your doctoral thesis data into this, and we'll remove it for you. Okay. Now, all right. So what was I was going. So we'll press on. We're up to page 16 on the manual, looking at Uber strains. How are we going? We've still got people tuning in. So. When you have a lot of data, when you have data like this that's being uploaded from multiple sources, you run into a interesting problem where you have the same strain, but it's just been resequenced over and over again, or it's been provided by different data sources or something like that. It is still actually the same strain. Oh, I'm in development. Oh, I've got to go to the other one. So it's still the same strain, but so they should really be grouped all into one collection. Now in EnteroBase we call this an Uber strain, and I'm going to show you a very quick example of what that looks like. So a classic example in Salmonella is LT2, which I think is a lab strain. Yeah, and so name contains LT2, show substrains. You'll see all of the ones underneath it, and I'll show you what this looks like. This is an Uber strain of LT2. It turns out this data source is an accession number to a complete assembled sequence. So the complete RefSec genome is here as the top level thing with all of its information. And if you click on this little arrow there, there's all these other records. So these are individual records in the database, but they're linked to this Uber strain. Right? So LT2, legacy data records, there's sequencing that different people have done, and they logically should all be joined together, and they should be treated as a linked record. When you look at 7-gene or RMST data, then you'll see that there is. Why is this new?
Why is this new? Yeah.
Oh, right.
Too much missing data.
Oh, too much missing data. So this one, the sequencing for this was kind of bad. The genotyping didn't work very well, and it came up as a garbage entry. So all of these sort of records can be collected into one single Uber strain. Now you might say, well, how do I make my own Uber strain with my own data? So I'll show you this in the sandbox actually. If you go to the sandbox, you can follow along with this as well. It's quite simple. So my strains, edit mode, and tools, add to Uber strain. Okay. You click that. You click the master. So let's say bug 1 is actually the one strain, and it'll say master strain bug 1. Please select substrains to add to master strain and press OK. So bug 2 and bug 3. Okay. Right. Whole thing's there. Gives you a whole summary. Press OK to add substrains to master. OK. And now these are attached underneath this. So this is when. So often you have projects where you do resequence the same bug over and over again, or you have legacy records, you have MLSC records to tie with genomes and so on. So that's where this tool comes in to be really powerful. And now when you generally search, you just see this one record, which is the master record that you interact with. And you can go into this if you want. Okay. So any questions about that? Does anyone have any problems? Yeah. So I think it's this tools Oh, just select them, remove selected from Uberstrain, detached. All right. So
Sorry, I did have a question. Is it only your strains that you can add as each strain?
yeah, it's only your strains. So yeah, if you're a curator, you have global access to the database, and if you're interested in tidying that sort of thing up, you should get in contact with us. But this is really for your own data, so that you can keep it all tidy. Okay, so we'll move
The
on.
advantage of an Uberstrain is it allows you to see if there are discussions. So we found this to be very, very useful when there are actually multiple sources of data for the same strain. Sometimes on legacy and sometimes on genomes. And if they're discrepant, something has gone wrong. And so you can see that immediately by looking at the Uber strain and what the such things are. So it's consistency there. And it's very useful.
So can anyone see my question? I'm in China. Okay. What's his name, Jemin? Huh? Wang Lia. Yeah. Hey, mate. All right. Good. All right. So we'll come to the.
What doesn't work? Somebody says it doesn't work.
It doesn't work. What doesn't work, Miguel? The Uberstrain doesn't work? Oh, Miguel can't. Oh, your job's finished. Yeah. So I'll discuss. We'll coordinate on what's going on with that one. I'm not sure what you're trying to achieve by killing the job. So I'll talk to you later. Right. So we'll just press on for the last part of the session, and then we'll break for lunch. Finishing above time, which is great. I think this is the last bit, which is just downloading data, right?
Mention that for all the rules from Story Archive, if you are the real owner of the data.
No, not Nabil-Fareed. No.
Okay, yeah. So that's a good point from Jemin. That so we don't know when we pull it from NCBI, we don't know who created that data or who to contact or who's interested in looking after that data in EnteroBase. So if you are browsing EnteroBase and you look at some strains and you say that's my data actually, then you should get in contact with us and we will assign you as the owner for those records. I'm trying to find one from. A lot of it, even though you think that you've done the sequencing, whatever, a lot of it is done. If it's done by the Sanger Center just uploads it under their name. So we don't have any way of tying it back to you or anything like that. I'm trying to find one from the GBRU.
And on top of it, the Sanger Center very rarely puts up metadata. So if you want to put up your metadata for something sequenced by the Sanger, make it your strain and then you can edit it.
No, Sanger's on the first page. I was looking for Phil Ashton's records because he kindly puts his emails. So, but that's all right. But yeah, yeah. So under lab contact, you can. But get in touch if you see your own data floating around EnteroBase and you want access to be able to edit it yourself.
Who's this guy from Australia?
Vitaly Shinchenko. He's at University of Sydney. He's doing a sabbatical with Martin Maiden at the moment. I think it's University of Sydney. He was going to tune in today, but I'm not sure what happened to him. All right. Okay, so the last part for this session, and then we'll have a break for lunch, is downloading data. So current data can always be saved to file by data saved to local file. So if you are in MIU or wherever you are, if you're in a search window like this, you go to data and save to local file. Now this again is like downloading the metadata file. It comes down as a download. It's not like a file that you save into your system. So you just say test meta whatever you want. And I'll switch to Excel so I can show you what this looks like. So bear with me for a second. What's the matter? What's wrong? What I do? Everyone's laughing for some reason. Test meta text. Oh, okay, I see. So this, oh, hang on. I'm in the wrong one. So I'll just copy this one. So, this is from another. Is that shown up? No, that hasn't shown up yet. Hang on, I'm sharing the wrong spreadsheet from before. Sorry.
You're showing the right one.
Test meta. There you go. That is the. Is that showing up on your screen?
It takes a moment to show up.
Okay. Yeah. So this is the saved data, saved to local file, and you can import this into Excel, and you have all of those records that I was looking at before. So we were just talking about Vitaly Shevchenko, and these are all of his records, some of his records in there, I think. Well, anyway, they're all in there. That's Derek Brown. Always up and running. So, and it's got all of the metadata attached to that. So source and locational information, accession codes, and so on. And in this case, it's attached the assembly. So one thing with the download is whatever information is in the experimental data, it'll give you this entire snapshot, what's open at the moment. So if you were, say, you weren't interested in assembly data, and you went to, oh, sorry, I've got this. No one else can see what I'm doing. Jumping backwards and forwards. Okay. Okay. So in that example with that spreadsheet, is I had the metadata and I had the assembly data because that was what was open. If you see, I set this to 7G. I have my records I want. I can see, ST, BBG, so on, numbers. And then I save this to a local file. Right? So we'll say test, MST something, save it. Now let me import it into Excel and then I'll switch over to show you what it looks like. You can just only drag and drop it. Yeah. Right. Let's see if that's okay. Okay, so for everyone following at home in TV land, I'll just switch over to the spreadsheet. This one? Yeah. So what you get is you get all of the metadata associated with the strain, which is fine, which is what we had before. But then you get this experimental output as well. You've got the ST, EBG, and the MLST, 17 MLST profile as well. So, so just by choosing, oh, I'm sorry, I'm showing the wrong screen again. Give me spreadsheet. Here you go. Yeah. So if you, what the output is controlled from the save to local file. From data saved to local file is dependent on what experimental data you have open, and the strains you've got selected, the strains you've got in the window in your search results. This is about science, yeah. Yeah. I don't know.
You're publishing this to everybody in Google and Android.
No, it's not. I mean. So with someone, okay, fine. All right. It does. No, the actual science, now that we've gone through all of the functional stuff of how to upload data, download data, play with things, search things, and so on, will come in the next session after lunch. So we'll adjourn from now till, I think in the agenda I had 1:30.
We didn't do download an assembly genome, that's just downloading the metadata.
I showed you the download the assembly genome.
Sorry.
one.
That was one genome at a time.
That was one genome at a time.
Oh, I think that's on
sorry.
assembly.
Oh, was that the same? Sorry, I just.
So, okay.
Excel was-
Okay, I'll switch back to that on the screen so everyone can follow. The question was about how do I download a bunch of genomes? The actual assembly sequences on top of the metadata and experimental data. So everyone can see this. You can click on this and you get one at a time, or you can select a bunch and go to this button up here, download selected assemblies. It'll download them one at a time, and it'll just flood your download folder, but they'll all come there. Yeah, and you can download them through the API as well, but I don't have any course materials for that. But that's a couple of ways you can get your assemblies out.
Maybe that's the point you need to make, Nabil, is that you're showing how to do this manually, but there's an automated program interface for computer specialists who can do major manipulations and uploading and downloading data.
Yeah, so there is a yeah, so there is a API that we're not covering in this course, but if you need more information of how to download lots and lots of data programmatically to scripts and things like that, then you can email me and I'll show you how to do that. We have a few walkthroughs of how to do that, tutorials and things. So before we break, there's one more question about how do we get it to Excel format again? Okay, how do we get it to Excel format?
How do you get it into that? So how does Excel open? That's what it's text file.
Well, one of the easiest ways is if you have the file. I can't just show the screen, I suppose, or maybe I can. But if you have the file, the text file, you can just drag and drop it from your file system into Excel, and it'll just open that way. The other way you can do it is if you go, let's get book one. Here's a blank spreadsheet, which hopefully you can all see. You all see it? Yes, you can all see that. Blank spreadsheet, and you can, I think it's from text. Where is it? Always messes me around with the data. And you can import data that way. It'll ask you to delimiter, tab, finish. Yes, put it in the existing worksheet, and there you go. So it'll change, this exact option will change on your version of Office, and I don't have an encyclopedic knowledge of how to do this on every single operating system, but basically you can import your data from a text file into Excel. Most modern implementations of Excel allow you to just drag and drop it, and you might be able to get away with just opening it from your computer as a text file if you set it as a text file as well, as another approach. Okay. Okay. So we'll break for lunch. Yeah. And so I'll leave the feed open. I'll leave the feed open so that you can come and go as you are. I have to keep this open to keep broadcasting, but no one will be around really, or maybe. And we'll come back in about, when did I say, an hour? 1 hour? No, I think 1:30. So it's 12:35 for us right now. I know people are in different time zones, so 1 hour. Set synchronized watches. In 1 hour we'll reconvene. Okay. So 1:30 British summertime.
The documentation sort of loads up. You want to keep the manual, then I'll just print up another copy of it.
Yes,
We're gonna put lunch now. Did you order lunch or did you brought up here or are we going somewhere?
No, cafe. I got a credit card. We can ring up.
Yes, yeah.
Excellent so far. Oh, cheers, Derek.
Just classic feedback.
Oh, that's amazing.
Yes, Kenny?
That's chaos, isn't it? It's any little bit. Let's get something up.
It wasn't a PhD laptop.
You've got the key. I wouldn't do anything bad. How good is that?
So if you're still tuned in, after lunch we'll be covering chapters 3 and 4, which is where you actually get to do something with all this data and do interesting stuff. So I'll see you then.
minutes.
Eh?
Oh, it's warm in here.
It's warm. Air conditioning, all right.
Alright, so I think we've answered that one. So format.
Well, yeah,
I can't see what the issue is.
it's not just measuring, it's changing behaviour. We can incentivise people to do that. So, there's no argument about if we measure the height of children, not the grade. If we do it. But in this situation, it's say, well, yeah, if you are changing, people will change their spaces. So, instead of publishing in the journal, general you know, I mean, the interesting question is, can you measure that? To actually say, this was the trajectory of the site. Well, exactly. I mean, the short term is hard to think of what could you do better. Would you have to say, oh, we just don't do anything for it? Or just let it go to what? Or just measure something and then
So Martin,
Yeah.
you're happy? You're taking
Yeah.
chapter 3, yeah.
I mean, the one that was most similar sites, Birmingham, and they had been telling us about the national students. Again, this is one of the issues of starting to register. What they said was anyone who
Can you send a message?
About the lunch note? Yeah, it's a bit ridiculous. Yeah, it's a bit odd.
They said, if anybody feels like doing it, I'm going to cut the head off this something.
Oh, okay.
That's quite serious.
If anyone,
Yeah.
oh, okay, cut their head off.
No, I don't know what it was, but they said they can take it to the police up there, isn't it?
Yeah. Well, I mean, you have. Well, I mean, they have to do something, right? They have to do something. This mic's live, by the way.
I'm not going to say anything.
Okay.
I'll tell you what.
All of our fans in China will be watching it.
Yeah.
Hi. So we'll start in about. We'll start on the dot of 1:30, I guess, which is 2 minutes by my reckoning. Is it 2 minutes? Maybe I'll watch this slow. Yeah, it's about 90 seconds by my clock. So if you're still with us from elsewhere, just give us a little nod in the question thingy.
Really? Well, I mean, it's questions the fact that the last one I spoke to was only about 3 weeks ago. So they are. Your phone ages ago.
Still here. Oh, hey Derek. Oh, cheers. Jim got me a coffee. Best day ever.
It says cannot connect to the wireless. My wireless is definitely on. I've taken the top sensor off. I'm not connected to the router or anything like that. So what usually happens is that my clip
Alrighty.
connects to the network. They don't password.
Do we still have Karina in Galway with us? Just leave us a message. You can use the chat actually. Actually, should I send an email?
Well, it's usually it's not,
What do you think?
character type, and they've got this study where they're using people start
Materials.
My colleague was with me, but the same thing as well. I've never had a problem That's his come up. Yeah.
There's a part of me that's
Yeah. Yeah. Not that concerned.
about Clonal and something, you can't really
I found it right.
You don't want to copy.
I'll see.
Alright, well, okay. Still here though, although today is a holiday in my region. Is it? Someone's National Day today. Norwegian National Day today. Hakiz is still here. So
Susanna, say hello to Susanna for me.
you can say hello.
Ask her if when she's coming.
When are you coming, Susanna? When are you visiting us here in Warwick? Alright.
What did she say?
I guess she'll respond in a second. Okay, so before we start again, we have a question about, and the other thing is when I opened the assembly file, it opened with the program that is currently in this PC, serial cloner, but it failed. Okay. Yeah, it's a faster file, so it's just a straight text file. So if you open it with Notepad or TextPad if you're on OS X, that should be. Mega can open it?
Yeah.
Okay, Mega can open it, but just a straight text editor can open those files. So, yeah. So I don't know what serial cloner is. That's not the correct answer for that one. All right. Let's see. The Portuguese are back. Who else is around? Okay. No. Okay. We'll get back. We'll get started. All right. So the third and fourth sessions are talking about how we spent the first part of the day talking about how to just use EnteroBase and how to put data up and pull data down. Just arrived from lunch. Okay, ready. So now we're going to try and talk about how you actually get anything out of it. How do you do analysis and how do you interpret those results? So I put together, if you read the slide set, the very basic overview of sort of the main concepts that EnteroBase is based on. And if you have a grasp of this, then a lot of the behavior in EnteroBase makes a lot of sense. And it's how you get the most out of the tool as well. So I'll start at the beginning. The beginning is multi-locus sequence typing. So the idea of multi-locus sequence typing was to get away from genotyping methods or phenotypic methods or pathotyping methods that didn't necessarily reflect the underlying genealogy of a particular species. So in this classic paper of Maiden et al. 1998 in PNAS, they describe doing this for Neisseria, they meaning Mark, who's sitting here, and they used a set of gene fragments from housekeeping genes scattered from all around the genome, which is, you can see the locations there in the figure on the right, which is taken from the paper. And the concept was that they would give a unique, non-identical sequence, so each allele sequence that was unique, and it wasn't identical to any other ones, they would give that a number. And then that, and for the 7 loci. And that range of numbers would give you a sequence type. So if you look at the bottom, there's a sort of mock-up of one where each allele is, so it's a sequence that's given 1. Even if there's a single base difference between, in say, in ARR E, there's one base difference between number 1 and number 4, they're still treated as completely separate alleles and they're given different numbers. And that string of numbers gives the different STs, and there can be combinations of numbers or combinations of new numbers. And using that profile, you can build a tree from that, based on the number of different allelic differences between any of your strings. In EnteroBase, we like minimum spanning trees, which actually doesn't do any real phylogenetic construction. It's just it's a clustering method. And the idea behind it is very, very simple. Given a set of points, data points, you just calculate the distances between these data points and you join those together, which have the highest score. So in this figure, I've got ones which are, say, they're 12 away from, like B is 12 away from, is scored 12 between B and E, and A is scored 4 between A and D, and you get this sort of map. And the lines between any of the points in the second part of the figure is the one that they most, is the one with the highest rating that they connect to. And you do this for all of the data points, and you join all of them together. So it is basically a spanning, it's a tree that spans all of the information. And then if you weight it based on the weighting metric, you can immediately see that they form into these clusters based on that sometimes. Now, that's a rough conceptualization of what it is, but what you can do with genomic data is you can substitute that allelic profile and then generate that using MLST data. So since the conception of the first MLST scheme, which was based on 7 genes, we've had a number of other schemes that have come out since. So they've arranged, like in classical MLST, they're anywhere from 5 to 15 loci. Usually these are conserved housekeeping genes, and they tend to have different schemes for each of the different species that they're geared towards. Then came the publication of ribosomal MLST, which uses ribosomal protein encoding genes, which is 52 loci. And these are, again, highly conserved. And because you have more loci than, say, 7, you see a lot more resolution, and you can be a lot more discriminant. Because they're ribosomal proteins, arguably they are applicable across all of life, and there's a tree of all of life from the RMLST publication that they show that it works. And then recently we've had the introduction of core genome MLST. So this is where you're now jumping from 52 loci to, say, in the case of Salmonella, up to 3,000 given loci. And you're no longer you don't necessarily care what the sequence is. It can be housekeeping genes. It can be any conserved coding sequence or gene fragment that you want. And because you have so many of these, the profile is highly variable, and you have high resolution from that. But you have to have a different scheme for each species or genus because you don't have the same coding genes between different bacterial species. One concept that I'll introduce in the second part after Martin does a little demonstration is the concept of e-verse groups and clonal complexes in EnteroBase. So I think I already explained what an ST is, which is that allele profile, which gives that which is given a unique number. But I think it was in the, was it Salmonella? Salmonella was the first CBG description, right?
No, clonal complexes have been around from the beginning.
Yeah.
But nobody was just on the EBGs. I think Salmonella still is on some, which is another thing.
Okay, so yeah, in Salmonella, EBGs is just anonymous with clonal complexes, or synonymous with clonal complexes. But the idea of both of these is the same in EnteroBase, where when you look at when you look at a bunch of strains, so these are this is a collection of a bunch of strains on the right, and each of them represent separate STs. They're all separate STs, but you can see that between all of the ones in the blue cluster, for instance, they're all one allele away from each other. So they're all closely related. They're just differing by one allele, and they're in this sort of continuum, all close to each other. So if you looked at it by eye, even on a tree, you'd say that these are all sort of related. This is one that's led to another, which has led to another, which has led to another. Whereas in the other case, you have the orange cluster, which is a little bit further away, and you see these sort of discrete groups, and you'd say this is, well, actually, if you look at orange compared to blue, blue are all in continuum, they're all closely related to each other. Orange is all closely related to each other, but the two are separate. And so we would put them into separate clusters. And that's where your idea of clonal complexes come from, at least as far as EnteroBase is concerned. There are slightly different definitions of clonal complexes in other species, but this is the way we do it. But then the question becomes, where do you draw the line in terms of allelic differences of what defines a cluster? So in 7-gene MLST, we use 1 out of the 7. So 6 are similar, one different allele out of the 7 MLST loci. In RMLST, we use a cutoff of 2 differences. And in CGMLST, we haven't quite decided, but we tend to use 1 to 200. And Martin will show you how you can sort of play with that number yourself, actually, in some of our analyses. These wider clusters are available in Salmonella and in E. coli. They're not. E. coli doesn't have an REBG defined for it yet. We do have REBGs defined in Salmonella. So this is this is when you take our MLST data across all of Salmonella, which I think at the time was about 30,000 Salmonella genomes out of EnteroBase, and you build one of these minimum spanning trees. And this is what I mean about those clusters. So each of those, you can see the this is in Salmonella. This is Typhimurium. These are the big major clusters in Typhimurium. These black lines between them shows that they're one away, and they form this big structure on their own, which is distinct from other clonal complexes. So they're distinct from Typhi, or distinct from Enteroidetes gallinae and Clonal over here. This figure has been color-coded with the... So this is based on RMLST that we've drawn the clustering, but the colors is based off EBGs from MLST, and the point of it was to show that they're largely concordant. So while a lot of people have moved with MLST and they've jumped immediately to core genome MLST, we actually find RMLST as really useful because it gives you more discriminatory power than 7-gene MLST. For instance, this complex of Enteroidetes is broken up into smaller groups with RMLST, but it's still concordant with MLST. So it's like, yeah, so it's more discrimination, same concordance. There's a few exceptions, but for the most part, they're largely concordant. Yeah, so, but this particular figure was generated with binumerics. This wasn't part of EnteroBase, so no, you can't have this figure yourself yet, unless you find that software. I'll show E. coli as well. So this is the same thing applied to E. coli, where we're looking at RMLST across the entire Escherichia genus. And again, the color, the tree was built with RMLST, but the color coding is using the MLST clonal complexes. So the big brown group over here is ST131, the Soniae, there's a 157, vaccinary. Your K12 is in here somewhere in this light blue one, so on and so forth. So all of these, but the point of these methods for you as a user is to think about, I have a strain, and I want to know who are his neighbors. What is this closely related to? And each of these ways of classifying data, be it at the 7-gene level, the RMST level, the core genome MST level, allows you to choose what degree of resolution you want to make that call, or how closely related or how distantly related you want to make your sweep. But the point is ultimately, who are my neighbors in this case? And that's what we sort of build a lot of the logic behind EnteroBase is that you have these clusters, and you sort of start from the population up and you're drilling down. You're always stepping down. So you might work through EBG or 7-gene. Once you've defined that as a data set, you'll take that, you make that a workspace as we showed before, and then you do some further analysis on that, and you keep refining down till you get like a set of data that you want to work with. And from that you can launch into other analyses. So that's what I wanted to cover basically for population structure, which we'll cover towards the end of this session. But now I'm going to show you a case study that we did applying our CGMST scheme to a salmonella outbreak in the UK from 2014. So all of this data and the actual analysis for it was done by PHE at the time, and what we did for it was basically just go back and revisit the data and see how ours compared to what they found. So it's an outbreak of, I'll just check if everyone's still with us. Still here, yeah, everyone's fine. So it was an outbreak of Salmonella cerevisiae enteritidis. It was June to October 2014. The source was contaminated chicken eggs from one German company that had been imported multiple times into the UK, and it had a specific phage type, which is what tweaked them off to it in the first place. So what we were wondering was, how does this, when we take this sort of data, this is real data in an outbreak scenario, how does our CGMST work? What does it look like? And how does EnteroBase, sort of help you with investigating that? So this is a core genome MLST minimum spanning tree of just enteritidis. So this figure is generated with bionumerics at the time. That's what we had to use with it. But all the data was fetched from EnteroBase and loaded into bionumerics, and so that was the data source, but the visualization was done by that program, by a different program. In it, we've got about 6,500 genomes, and this is where all of the outbreak strains were sitting. They were sitting on their own cluster away from the other enteritidis here, which are here in green. And this is just that. This is just that cluster of the outbreak cluster. So the outbreak cluster is here on the left, this group, and these are the ones that are closely related to it. There are about 70 allelic differences out of the 3,000 we had in our scheme. So they're close, but they're not actually really big. They're not part of the outbreak, but they're the next closest thing. And in the original outbreak report, they'd said that it was coming from they'd found it in multiple geographic locations across the UK. So they'd said Cheshire, West Midlands, London, and Wessex. And so we took that data, we took that metadata, we took their sequencing data, and we built our own minimum spanning tree of the outbreak, and we applied that on top of it. And you can see clearly there are separate clusters that relate to geography that you can get out of that MST data. The nice thing about EnteroBase is that not only were we looking at just the PHE data, but we pulled in all of the data that we had in our database. So we actually picked up about 5 strains that the Institut Pasteur had just uploaded themselves, completely unrelated, but they were there and they showed up to actually be part of that outbreak cluster, so they were associated with that. And we also found this intermediate in the United States. Now this is not part of the outbreak, but it's closely related, which draws to the question of where did that come from, and was there someone who went, while this outbreak originated in Germany, maybe someone went to the States as well as it coming into the UK. Maybe it came into the States as well. Maybe this is someone who just had bad eggs in Bavaria and then went home. Anyway, so and then you see the same. So we then applied it with the temporal information, and then again you even see good clustering. So what I've done is I've color coded it. The green is over time, over the span of the outbreak, where the darker green is at the start, like about April 2014, and the end is towards December 2014. So you can see like it started first in the West Midlands. There's a few cases in London, but then there were a few later, and then the Wessex one was sort of in the middle. So you see that, and where's Cheshire? Cheshire's here. So Cheshire, yeah, you see these two groups were somewhere in the middle, and you see that again with the epidemiological data they presented in their paper. So West Midlands was first, then London, then Cheshire, then Wessex, then London again, which is what we have here in our tree. So all of this information was readily available in EnteroBase. It was just a matter of, as I've showed you, files save, metadata files save, experimental data, fetch that down and just load that into something that throws these figures. At the time we didn't have a method of drawing these trees, but now I think Martin is going to show you a way within the program itself you can actually interrogate this kind of data, which we've been working on. Okay. Cool. Oh, right, okay. Which was the window you had? No, that wasn't it. This one? Yeah, I got it. I'll attach you to that window. Yeah.
It's the wrong message then.
Hi, so I'm going to be working from chapter 3, page 18, search and outbreak strain. So first thing we're going to do is go to the Salmonella database and select a single strain, and then pretend we've just uploaded it. So here we go. So we're going to load this strain. Here it is. And we want to see whether this is part of an outbreak and what its closest neighbours are. So initially, as we've said before, we just get the assembly stats, which isn't that helpful. So we're going to look at the 7-gene MLST. You see it's serotype 24, and the predicted serotype is Javiana. We can see that in the metadata they didn't actually put a serobar in there. So we want to find strains that are similar to this, and the way we do this is by right-clicking on this table here and going to find similar STs. So in this particular case, we're going to look for STs which match by all 7 alleles. So basically we're going to find everything that's in ST24. Obviously we can reduce this number here so we can find partial matches. This comes in more useful when we look at ribosomal MLST and core genome MLST. But for the moment we're just going to check everything that's ST24. So here we go. Okay, so there's over 480 strains. Some of them are legacy, so they won't have any genomic data associated with them, but that doesn't matter for our analysis. They'll just be ignored if we do genomic analysis on them. So what we want to do now is save this as a workspace. So workspace save, and we'll give it the name ST24. Okay. So now we can see this analysis button has come up. So the idea is that like trees and hopefully working on SMP pipelines as well. These will be attached to a work group. And now here we're going to change the scheme to core genome. This is now looking, instead of 7 genes, it's looking at 3,020 genes. Because the first few records were the legacy ones, they haven't got any information, but we can see that the ones derived from the short-read archive have got a single ST number. We decided not to put all 3,020 alleles in this table because it probably wouldn't tell us a lot anyway. But you can download them by going save all, and this will take a few minutes and they'll be downloaded as a normal text file if you want all 3,000 alleles for each strain. So what we're going to do now is build a tree. So we go to Analysis, Create MS Tree. Okay. So we've got the, yeah. So this is running in EnteroBase. So we're going to call it ST24, and we submit it. Okay. So this another window should come up and it's calculating the tree. So this actually sends a job to Zemin server. He's written his own algorithm for the minimal spanning tree. It's finished already. It's just rendering it now. So here we go. So
this is not for people who get seasick.
Is this function on all of the pathogens?
Yes. So you can zoom in and out using your mouse wheel, and you can move it just by dragging.
Oh yeah, it's attached.
Okay,
yeah,
sorry. It's opened in a different window, so you couldn't see that window.
Thought that would have.
I'm going to swap in between.
Yeah, well, let's share the entire screen.
Okay.
So now you can see the entire screen, and that's disappearing into the background. Here you go. So, yeah. Okay. So everyone should.
Okay. So can everybody see the 2 screens now? Yeah, is that, yeah?
Now I'm seeing you, I'm not seeing the feed. No, now it's there. Okay.
Can you see both? Yeah?
Yeah, it's just this is slightly there.
Okay. Okay. So first thing we're going to do is try and find our initial strain in this tree. So what we can do is go back to our main data, and we go to this filter icon here. We're going to filter on name, and the original name of our strain was okay, so here we go. This is our original strain, and then we can highlight it, and if we go back to our tree and press on highlight selected, there we go, it's here, and you can see this part of a big node, so this looks like
you're going to be losing people, Mark, because the delay is half a minute or something before this.
Okay.
So I'll tell you when I can see it here. That's within the university. I'm going to see that. No. Okay. So go ahead.
Okay, so we know the strain that we initially picked is within this group here. So you can manipulate this tree in many ways. As Nabil explained, the link distance is the number of differences in alleles. So we can increase the label size or the node label size. Yeah, link labels. So here we could see there's 429 differences between here and here, but our strain was here within this group here, and you can see it looks a bit messy at the moment. So what we're going to do is take a subset. So to select things within the tree, you press Shift and then drag, okay? That's it. There's a bit of delay on it. Okay, so we're going to select all these. Oops. Okay, I missed a few there, but and that turns red. And then we're going to filter selected, and this will filter all the ones we've shown here in the table previously. Okay, so if you go back to our previous table, okay, is that on yet? Yeah, okay. So you can see here now that although we started with 483, we filtered out 175. And we're going to build a tree with these 175 again. So we go to Analysis, Create Tree, and we'll call it, I don't know, Outbreak 1 or whatever. And yeah. Pardon?
You want to select ones only, right?
Yeah, it'll just do the selected ones, yeah?
No, you have to check it, right? That's all.
No, selected only. So it does everything that's on the screen, either filtered ones. Selected ones only will only do ones you physically selected with a tick, yeah?
Right.
Okay, so we want all these 175 that we've selected. Okay, so if we submit that, there we go. And again, it's calculating.
Okay, hang on.
So now we can see that looks a lot better, yeah?
Looks like fire.
Yeah, and we've zoomed in on the ones we want. So you can color code these by any of the metadata. So if you look for source details, you can see that the original ones here that we looked at were actually from cucumbers.
Right.
Yeah, and I really like cucumbers. And we can adjust what we actually show. So we can actually show the strain name if we wanted, or the category. And increase the label. So there's lots of things you can do to play about with this this tree. So that's basically it. And once you have the tree,
The white ones are pond water?
well, allegedly, it's just true, isn't it? Yeah,
Pink salmon ones.
yeah.
No,
It's on there twice, probably. One in the packages and one in there.
Yeah, it doesn't differentiate. This one we need to clean up the data, yeah?
you're saying, oh, but you know, interestingly, they're not related to each other. Pond water is not related to Castle Pond, Castle
No.
water,
No,
which suggests there might be two different studies.
no. Right. So there's information in the manual about manipulating the trees, but once you've created a tree, it'll always be there, so you can load it. You don't have to recreate it. You can load it again, and
You say it'll always be there
in that work group.
in the workspace.
Yeah, in the workspace. It's connected to your workspace, and you can have multiple trees open at once and manipulate them.
So if I did go in to change, so there's two pond water, so they have the same type,
Yeah.
would that then recreate the tree as well?
You'd have to create a new tree.
Is that if you change any method? Yeah, we can metadata fetch dynamically.
So the metadata is not fetched dynamically in this case.
Okay.
But if we look at, so for the source, we have source details, which is what people actually load in, and it can be anything up to like whatever. We get some really weird ones that are like 500 words long.
Can you go onto information, lab contact? I want to see who the two pond waters are.
Turn the labels off. Okay.
FDA.
FDA, but the other one
Is CDC.
is also FDA. They're both FDA. No, the green ones. Okay, green ones is CDC.
Yeah.
So their particular pond water is different from the FDA pond water, which makes sense. It's different epidemiological study.
Okay. Okay. So
That is why you want to have metadata in here.
Okay, Nabil?
Okay.
So,
How do you get that out?
Not export, no, just
okay,
print your screen. You can't export
but
it.
no, but it is an SVG image, so it'd be quite easy to just have a button where you press and you could say that's an SVG.
You should be able to do a right click on it and save it.
Yeah,
Save that.
yeah,
Okay.
but that would, no.
All right. Let's see. So
This is the first implementation of a minimal spanning tree connected to a database that is actually useful and usable. And I'm really interested. And Martin got the idea from people in Portugal who developed FiloViz, but their approach didn't work for him, so he started from scratch. And so he and German are very much to be complimented on this. What Martin didn't mention is this handles missing data. That's where German's algorithm comes in. And unlike all other minimal spanning trees, this has directionality. So if you have one with more alleles and the other one with more missing data, the arrow goes from more alleles to less alleles. So this is giving much cleaner minimal spanning than if you have all the missing data in there, which becomes very dramatic at this level of resolution.
I don't have the analysis, so we'll go to questions. If anyone has any questions, please put them on the question board.
He doesn't have an analysis.
Yeah, you'll refresh it.
Right. So yeah. So I don't have an analysis button. You need to first create the workspace, refresh the page, and then it'll show up. Okay. Let me know if that works.
Creation failed. There you go.
Tree creation failed. The message came up. Tree creation failed.
Tell them to get in touch with Martin.
Yeah. So if you did get the message, tree creation failed, just give a shout. Just email Martin. His email is on the manual on the front page, along with mine.
Is it possible to export it?
Okay, exporting the tree. So at the moment, there's no way, like right now, you can't export that tree. But I'm sure Martin will add it as soon as possible.
You can do a right click and save it.
You can write, can you right click?
No. Should be able to.
Right click.
It's not new.
Save that.
It's going to.
Oh, it's going to save it as a big web page, you think.
It's
So
still
no.
meant to graphics, so
You can have a print. You will have
Oh yeah, you can. Oh, let's see what happens if I do that. Print. And if I. Oh, this is going to done.
Yeah. Change the printer.
It's going to think about it for a bit. PDF. Whoops. Whoa, it doesn't like having so many windows up at once. It's sort of. Sort of.
No,
It's not liking it. Okay, so yeah, you can't export it quite yet, but we'll add that in.
Good question.
Good
How do you
question.
remove an MS tree?
How do you remove the failed MS tree? Good question.
I have to, yeah.
We'll have to add that in. We normally
Along with deleted workspaces.
Yeah, deleting workspaces and deleting failed MS trees are things you currently cannot do, but we will add that as soon as possible.
Yeah. Well, we use file of his all.
We just take a screenshot. Oh yes, the file of his developers are dialing in, and yeah, just take a screenshot. That's what I do for file of his online. Is take a screenshot. I'll just give a quick plug. If you go, actually, yeah, you can. If you go to file of his online, and if you don't like the look,
You have to make sure people see.
yeah, I think they can. If you don't like the look of our tree and you want to use FileOfViz, you're more familiar with that, then FileOfViz, online.fileofviz.net does similar minimum spanning tree figures like this. The nice thing is that if you go to profile data, this is, so what you can actually do, if I can find my EnteroBase window, you can just load your you can load data from EnteroBase directly into FileViz online and view it that way. So the same way, if you go save local file and you say, stuff.meta, save that file, download it, and then you go to a scheme of interest, let's say RMLST, and you say save all, and it'll fetch it down, and you say stuff.rmlst.tsv. You say save. Now those are downloaded onto my computer. If I go out of EnteroBase and I go to fileviz.net, I can just load them into this as well. So
Have people seen this?
yeah, they can see it. Yeah, they can see it on here. So what is it? Stuff.rmlst is So the RMLST data goes into profile data. Auxiliary data is your metadata. That's what they call it. So metadata, and we'll call it Entro Training, and we'll just launch it, and it'll actually go off and. Oh dear. Well, that used to work. But in principle, it does take tab-separated files. I'm sure the boys who are from FileViz who have dialed in today will figure out why that didn't work. But maybe I was too quick. Actually, I probably hadn't downloaded the whole file. Moving very fast. But yeah, basically this profile STs and alleles and so on, you can load. That is what you get out of EnteroBase, and you can actually just drop it straight into FileViz and use it.
You did RMLST. Take your RMLST.
No, RMLST works. I've done RMLST and CGMLST on the site. It's quite fine.
Oh, you got some missing data. I don't think it's mistake.
That might be.
Missing data.
Yeah, maybe.
That may be the problem.
Maybe I do have some missing data in there. But in principle, you can use.
ST is MD.
Yeah. Yeah, that's something to consider to do in that case. But so this is an alternative tool before the minimum signing tree, aside from ours as well. But they have the same problem that they don't give a vector graphic output. They just make you take a screenshot like we would. All right. So any other questions from the group? Okay, I think that's all the questions. If there are any more questions, please post them to the question board. And right. So to close, I was going to. So I started talking about with the slides about clustering and population structure within a particular species. I'm going to show you how you actually interrogate that within EnteroBase. So the trick is, let's get a fresh search. So if you're doing a search, all of the magic happens. I think my computer is running very slow, unhappy for some reason. Actually, it might be because I don't want to close it anymore. Okay. So in this case, all of the magic. So when I was talking about EBGs and STs and everything, that's all hidden under this tab in the search. Experimental data. Experimental data is generic. It will take any of the columns that you'd normally see on the right-hand panes and put them here for you to search it. So when I was talking about EBGs, right, and so EBG, I showed you EBG4 was Enterovitis gallinarum and palorum. You can just put EBG contains, would equals work? Equals 4. Off it goes. It'll take a little while because there's about 7,000 or 8,000 records. Let's see, 8,000. There are 8,000 records of EBG4. It says all EBG4 here on the right-hand pane, and we have all of these records. So even if they're not classified as enterovitis in the Theravar data, because we generate the ST from the sequence, you have all of these relatives for you to look at, which is very useful. And the same thing applies for RMLST as well. So you can do a discrete ST, so ST313, which is typhimurium. All your 313s are there, and you can manipulate them. You can draw. You can take this, make a workspace, draw a tree of all 313 typhimuriums. Lineage and subspecies is there for Salmonella as well. The same thing applies in RMST. You have RST, RMST, EBG, and an interesting one is the Cerevar prediction. So if you read those, there's a citation in the slides that points to a paper that Mark and German did on comparing clonal complexes in Salmonella to Cerevars, and found that EBGs, these clonal complexes I was talking about in the slides, is largely concordant with Cerevars, and actually is a better way of doing it, an easier way of differentiating the Salmonella. Using that concept, we implemented Cerevar prediction for records based off their EBG. So their EBG tells you what the Cerevar is going to be. So, and that's what you get in this field, Cerevar predicted. And Cerevar prediction is based on EBGs in both 7-gene MLST and RMST. So these are all typhimuriums. Now, even if, the nice thing is because the EBG is something, or the ST is something you get out of the sequence, and that's consistent with Cerevar most of the time, even when they don't tell you what it is in the metadata. So this metadata on the left here, typhimurium, this is uploaded by Sanger. If sometimes it's not there, sometimes it's just blank, and you don't. So for instance, these from J. Hinton, they don't have any information. You don't know what these are just by looking at the metadata. There's no information. All you know is they're from Malawi. Okay, great. But this tells you that they're typhimurium. You know that from the ST, and you know that from the Cerevar prediction. You know how confident you can be in that prediction by clicking this eye. If you click the eye, it gives you a breakdown. So what we do is for the EBG, we look at all of the Cerevars that are specified for that EBG, and we come up with we do a consensus score. So out of this, it's 313. People call typhimurium a lot of different things. Majority of the time, they call it typhimurium. That's why we call this we predict this as typhimurium. But they call it. There's a lot of strange stuff in there. I don't know why you confused typhimurium with Kentucky, but there you go. There's one more thing with the eye I wanted to show you. So there's another eye that's interesting. Right, and the same thing applies in RMLST. So RMLST, you have an RST. So this RMLST ST is consistent with the RMLST database. So this is an actual RMLST ST that you can find on PubMLST as well. So we synchronize these two schemes together. So this is like an actual number you can publish with and you can be confident with. If you click the eye again, you get another breakdown because we're looking at type. The numbers are slightly different because this is looking at a slightly smaller set. It's just within the RMLST EBG. But again, you have this breakdown of that prediction. If you click the eye, I think Martin, did you show this, the eye? If you click the eye, so on schemes that are really large, so RMST is like 50. So if we were to show all of the allele calls for it, it's this huge table that no one can understand. So we just have this little eye icon on the left, and you can see the breakdown of the locus and the allele call number, the allele designation number. These two loci in Salmonella are always undefined, so don't worry about it. They were excluded by Oxford because these two loci tended to be paralogous in Salmonella, so it was quite confusing, so they just took them out. So don't worry about those. But you always get these. You get the profile number. You can just check here. And the same thing applies with core genome MLST. It does take a little longer because there's 34 more alleles, but they're all there. Okay. So using these methods of clustering, and in E. coli we have similar approaches, you can actually place your strain in like a defined cluster and talk about it in reference to other strains. And once you define that, you build workspaces and you can go off and do all sorts of analysis on it. Let's see. Do we have any questions about that function with the search and the Cerevar prediction? So again, in E. coli we just have. So in E. coli, so again in E. coli you have the RST and you have the clonal, you have the ST complex in E. coli this time, and the ST along with it in the 7-gene scheme. There's also Cerevar prediction E. coli. This is a little different. This is not predicted using the clonal complexes, because if you remember from the figure I showed you, it's a little different. You don't see discrete clusters in E. coli as nicely as you do in Salmonella, if you remember from the slide. So it's a little tricky with that one. So this is based off sequence comparisons to known, which loci are you looking at? WXY and WXZ? Probably ZX and WZY. And fly, yeah. So those two genes in the LPS cluster are operon for O antigen and Phi C for the H antigen. We do a sort of similar to what's the one that they do in Denmark? Serofinder. Yeah, similar to that. We do a call of that as well. So that's available for E. coli now. That's a new thing. We're not 100% sure if it's working correctly. So if you spot anything spot any anomalies, let us know. But that's also there for E. coli, and that's a bit different to how we do it for the Salmonella. Okay. Do we have any more? Do we have any more questions out of that with the predictions and so on? I might have gone a bit too fast. No. Anyone?
Do you do any curation of the data? So how big the project is?
We'd like to.
We'd like to do curation. We haven't found the
So,
time. We're hoping to find this out that people want to curate not only their own data but other people's data. And so we're looking for curators who are interested in getting involved.
Oh, they sent me the. I wonder if that could work. So this is a picture of the tree coming from Philoviz based off that data set. So they went off and did that. Not the same data set Martin showed, but just the random first 100 strains in the database that I was trying to load into Philoviz. So that's the actual output.
Nice tree.
Yeah. So the question which online might not have heard is about curation and how we do the curation. We don't, yeah, as Mark said, we don't do any. We do very little. When we see it, we try and change it. But there's a lot of data to try and troll through. I'm supposed to be writing systems that automatically detect and all of that, but that's like a task. So, but yeah, ideally we'd want people, as you see errors, let us know and we can change it. A few people do get in touch with us when they see something wrong and they let us know. And if it is your strains that are wrong, then we can give you permission to it and you can change it and look after it. Okay. Question. For E. coli, I only find MLSD, RMLSD, and stats for experimental data. Oh, let's see. Cerevar prediction. Is that open? Cerevar? I thought we opened that.
Sorry?
Cerevar prediction.
For E. coli?
Yeah.
No, I don't.
Oh, sorry. I showed you something that I shouldn't have shown you.
Which database are you in?
I'm in E. coli.
So why can't you see it?
Because I'm an administrator.
Oh.
And these so we have secret things that we're running on. So CGMLSD for E. coli, which you probably can't see, will be out soon. And serotype prediction for E. coli should be out very soon. It's just a matter of opening it to the public. So if you're following along at home, you won't see those yet. That's a good point. You will in a few days, I think. We'll open that up.
Ask him if he wants to be a curator.
Yeah, do you want to be a curator on that and make sure that the calling is correct? I'm not sure if you boys are doing that down in Portugal or not. Do we have any other open questions? If that's the case, I think we've covered any other content we need to cover.
ask people to comment on what they're missing, what could have been done better.
From the course or from EnteroBase?
From the course.
Okay, yeah. So if people could post on the question board what they liked, what they disliked about today, that'd be good. Or they can email me, and maybe we'll go around the room. If you don't mind, can you put on the spot? Oh, the CRISPRs. Yeah, we'll do that quickly while it's up there. So
I don't think anybody cares about CRISPR.
CRISPR. Okay. So
It's only salmonella.
So in Salmonella, we have a CRISPR typing scheme that we've done in collaboration with FXFile in Pasteur. We don't know how popular this is in the community, but it's there, if it ever loads.
What's the difference between that and your RMS2?
Well, it's based on the it's based on CRISPR spaces rather than ribosomal proteins, but it's the same principle.
This is oligotyping and microtyping.
Yeah. Okay. Yeah. So it's analogous with oligotyping. There you go. And it has a little graphic involved. So there you go. You can see these are the spaces. Because these are all the same serovar, they're not going to look different, but they do look different from strain to strain.
And as you can see, there's a minus one, so it's not consistent with anything else. Once you click on the 526
Oh, there you go. So there's some ones with so those are different. You can see the different profile text views. And this is the pure text view of what it looks like, the spaces involved in that CRISPR profile.
This is CRISPR over CRISPR.
CRISPR is even it's not populated. We have to populate CRISPR to finish that.
Should be the latest one.
Should be for the latest ones? All right. So,
Concern for certain.
all right. So this is CRISPR, which is
Yeah.
which is only okay. So CRISPR is another scheme from Pasteur that we've implemented. It's only works for typing, so it's not, so it's limited in what it applies to, but yeah, it can be useful. Okay. We have a lot of questions. So, will SNPs be available? Have you compared your CGMST to SNP analysis?
That's certainly not.
So, Jemin, if you're going to answer, you'll have to come here and talk.
I should share my first. Okay, hi, I'm Jeremy. Yeah, I'm mainly working on the development of all the pipelines in works for EnteroBase. And now, yes, we are actually working on the core SNPs, which is a reference-based method. It's not going to be working on for the whole database, but it will working on each of the workspace. So it will be something similar to the minimum spanning tree. You pick a workspace and you pick one of the strands in the workspace as a reference, and then you can map all other strands onto the reference. And we will generate a SNP matrix and also generate a real maximal likelihood phylogenetic for you. And I think Martin is going to implement some sort of graphic interface for the tree as well. And in terms of comparing CG-honesty with SNPs, yes, we have done this for two different datasets. One dataset is the outbreak Nabil just showed you half an hour ago. In that case, we basically consistent with that. We find 3 clusters in the Clonal MST and also find 3 clusters in SNP space. They look slightly different, but in the groupings and the relative distance are all very similar. Another use case is the paratype C, color series, and type series. Sorry, there are 3 different servers in this large server complex. In which case, both CG, MST, and SNP can identify the 3 different servers clearly, and we can also see some substructures within each of the servers as well.
Okay, I think that comprehensively covers that. Yeah. We had another question.
Another
That's...
question.
I've tried several navigators. At the end, we weren't able to create a tree all the time. Tree creation for peaceful close the window.
Yeah,
All right.
this is a very
So,
funny.
so this is a funny bug. We haven't.
Can you tell us what browser?
Yes. If you could get in touch with Martin by email, send him a screenshot of what went wrong. Tell him which browser you're using, possibly the version if you can find it, and we'll try and figure out what went wrong there and get that working for you. Okay.
Yeah, there's one.
Yeah, there's an here's yeah.
That German topic. You're seeing Enterpolitica.
Enterpolitica.
And yeah, okay. Yes, we have set up a CG MST scheme for the whole Yersinia genus. That means we work on all the species in Yersinia, including Enteropolitica, and this CG MST scheme contains 1,600 genes, and according to my evaluation, it can be used to identify any kind of levels of substructures within Enteropolitica.
But it's not public just
currently it's under the alpha, beta, gamma, or omega testing phase.
Yeah.
Should be released.
We're still testing that, but yeah, we do have a working scheme for that, and we hope to make that available soon. Yeah, I mean, actually, that's a good point. So, sorry, may have missed it, but you mentioned predictive search. Okay, so there's two questions. I'll first answer this one and then that one. What was I saying? Yes. So, Morgane, if you can get in touch with us by email, we can actually, because it's in EnteroBase, we just don't have it available to the general public because we're not sure we want to release it into the wild just yet. We have to validate it, check it, test it, so on. If you want to get involved and just play around with that and see what you think, we'd appreciate feedback if you want to get involved in sort of just evaluating that scheme. Keep in mind, obviously, that if something we both figure out that there's something wrong with it, we'll have to revise the scheme or whatever. So it's not something you can publish. But yeah, if you want to get involved and play with that, that's fine. And that applies to any of the secret features that I've unwittingly shown to you and you don't have public access to. The other question was about Cerevar prediction for E. coli. Yes, the same thing applies. If you want access to it, drop me an email. I'll give you access to it. But yeah, if you want access to it, drop me an email and I'll send that to you. I'll let you have it, and it'll be made public eventually. How it works? So it works by doing. It's basically allele typing for three loci in the in the LPS. It's this. Is it similar to the serial finder paper? Or?
Yes. Yeah. I can explain this.
Yeah.
Yeah. Okay, I can explain.
Let's find it. No, it's down. It's gone into the chat. That's why it's.
Okay. Somebody asked, how is the Cerevar prediction working for E. coli? It's basically using specific genes for each of the particular antigens. For all antigens, we normally use WX, WJY gene, which are the two functional genes, which is, I think it's functional, is exporting the structured LPS out of the membrane, which is very specific for each of the all antigens. So by targeting these two genes, we were able to identify most of the all antigens successfully. And just for a very small group, they use ABC transporters to do the exportation. So in that case, we use WJ and WJT
the other 2 genes. They are also specific for the all antigen as well. For the H antigen, we just use splicey genes according to their sequence identity. We can do sub-clustering of the sequences into each of the specific all antigen cluster, in which case we will know that which all antigen it is. The cell algorithm has been described in 2 different papers, so I think we should be to make these 2 papers publicly available, because I sort of got ideas from them, so we should release them while we're releasing the scheme as well.
Yeah, actually we should add it to the, we'll add it to the manual in the, so we'll add it to the assessment.
Question, does EnteroBase have an API something between?
Yes, it does. Yes. Does EnteroBase have an API? Yes, it does. There is a brief walkthrough on the Bitbucket of how to use it. Hopefully everyone can see that. Yeah, you can see that. So, my computer is struggling for some reason. Yep. Okay. Am I still sure? I'm sure, yeah. But actually, I think my network's dropped out or something. It's not going very slowly. Yeah, it does. I'll email you a link to that if anyone else is interested. There's some documentation of how to get started with the API. You can fetch data like strain metadata and experimental data and everything.
Someone wants you to talk close to the microphone.
Okay. Ooh, I'm sorry to do that after lunch, actually. Yeah. So yeah, I'll send that around. We didn't include the API in this course because that's actually forms a lot of content to cover in a short time. So maybe we'll have another day if we have a lot of interest on how to use the API. Okay. Holiday.
Okay, say go on.
Okay. So I think that's all of the questions. I'll be sending around a little, just a wrap up debrief email, and if people want to send me feedback they have for the day, how they felt, what they liked, what they didn't like, what they.
Here, tell Lorena that she should be strong.
Okay. So yeah, we have used Mozilla and Safari. Try Chrome with that one, but yeah, we'll get in touch about what's going on there. Yeah, so I'll send a debrief email around, but that's I think the end of today's content. So yeah, thank you for it. Oh, is the CGM one final question? Is the CGMNST scheme available for download from API's OneFollow? Yes, it's available for download from the API. I haven't documented that yet, so I just have to tidy that up. But that will be that's coming soon. Yeah. All right. So I think I'll just close today's training session, and thanks for attending. Bye-bye.